access. Okay, so 5 days, whatever. This button is broken for the voice. The push to talk, whatever. And I don't think I'm gonna make it to, like 5 days. But if I do, I can try. I'm gonna have Siri read off the ECMA, the golden standard for JavaScript, and whatever. But I don't know. I gotta I'm gonna be testing some stuff today. It's gonna eat up my time of converting the program to 64-bit. I gotta just I wanna check some stuff. It's really complicated. 7 years is a long time. I wanna look through some things again. I'm not gonna optimize anything. I just wanna check some stuff. So I'm gonna do that, whatever. And I'll get back to yeah. I need some water. Converting it to 64-bit. Computer on.
Nine. 4. Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Return envrec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Assert. Envrec has a
I don't like the syntax for this. It's hard to read.
It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5. Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular
the strings, whatever. In my JavaScript engine, whatever. There's kind of a parsing part, whatever. When I convert it to C, to run as C, the strings, they get it looks like this.
Enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations.
If this is is JavaScript, whatever.
Abstract closure and a realm record or null, as parameters.
A JavaScript function, whatever. In my JavaScript engine, I have to all those strings. There's small strings, large strings, static strings, and then like there's like separate collections for all these different string types. There's like global strings, local strings.
Invoke the job abstract closure. Perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1.
Some of the strings, like the global ones, the mic's cutting. I don't know.
Jobs is a higher priority than other.
I have to like move them.
A priority at any particular time, script or module.
Up to the top of the program, and they get merged.
If all of the following conditions are true, get active script or module. Is script or module? If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of
into like a mega string. And then I hold I'll just say which string it is. I don't want to, it's complicated, but all of the local variables, the names of the variables, like if this name is Pixel Magma. In JavaScript, you can get the name of the variable. In C, you can't do that. So the name of the variable too itself, that also gets stored to an array. But these arrays of like strings and stuff, they're all over the place. And the common ones, it's I don't want to like give stuff away. I take advantage of the different memory regions of a C program because the CPU can do load and stores from multiple locations, like memory ports, whatever you call them, at the same time. So I organize things to try to get the most data coming in from different places, and it does make a difference. So like whenever I get rid of the name itself,
.org/
like maybe like Pixel Magma and like
value to propagate the incumbent settings object for promise callbacks. Field name value meaning callback, a function object, the function to invoke when the job is invoked. Host defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 hosts call job callback, job callback, v. arguments list. The host defined abstract operation host job callback, a job callback record, v. an ECMAScript language value, and arguments.
these all go to the same name, whatever, the 16 here, Pixel Magma. Up here, whatever, it's at the end. So like, let's just say it's a 16, the number doesn't matter.
Must conform to the
These fraction mix 1, fraction mix 2, whatever names that JavaScript, in the JavaScript code, that this is what chatbot made last time, whatever. some things aren't worth compressing, so I have to like expand it. So like I'll waste a little bit of memory for like friction mix when I could just like
Comma 5.4 host enqueue generic job realm. The host defined abstract operation host enqueue generic job takes arguments a job abstract closure, and realm, a realm record. And
I could just store friction mix 1, 2, 3, 4, and then anything that goes to friction mix.
time. The abstract closures used with this algorithm are intended
Would get that number, and then get like a subset number after that to identify like the ending to it. And it does do that for like the dynamic step, whatever. It doesn't matter what it's called, whatever. But there's like, I have wrappers, whatever, so like
turns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise.
I don't know. Once I convert it to run in my engine, it looks nothing like JavaScript, but it does the same functional thing, whatever. It does this, basically. Literally, it does this, but it's not going to look like it because it has to be split up into separate little pieces, and then I have a bunch of like every little piece of whatever that fits to the whole has a separate piece to something else, whatever. I don't know how to explain it without really explaining it and giving everything away, and there's no point being extra clear because most people wouldn't understand it anyways, and it doesn't matter because I don't know, it doesn't matter. All that matters is I get this done in 5 days. Hopefully 5 days. I'm gonna lose time now because I'm checking stuff, but
Tenable job is usually the result of calling get.
I want to find. There's different macros for strings and numbers and all these like different parts. I have to find the macros that relate to the strings, and then globals are separate from locals. So I have to like, it's like string, global, or local. It's really complicated macros. I have to find the macros that match. What would you call it? A macro that's like relative to the form of the type where it's at in the program. I don't even know how to explain it. There's global scope, there's local scope, there's function scope, there's a loop scope, there's a lot, whatever. I can use like global scope for like these things and do like a little speed test, but it's not fair because I haven't like things optimized for local scope. So I have different macros for global and local scope. So if I make a speed test and I want to run it and I use the global scope macros, it's going to be a little bit slower, but not really in some cases. It depends. So I want to like test between those two also. So I want to like convert what Chatbot gave me because this is some horde code. I asked it to make some horde code and it did. It's using the module operator. I never use the module operator. Like never. I'm gonna divide, do it any other way, get the remainder myself. I will never use the module. Not to judge anybody that does use the module operator. But I told it, Chatbot whatever, to make some like quote stress test code, whatever, to like test the whatever operations that have lots of inefficiencies stuff. And chatbot kind of knew, even though it's a chatbot, that the module operator is horrendous, which is why chatbot was actually kind of like correct in this case, because chatbot's like, oh, you want to like really test stuff, so chatbot decided to put the module operator once, twice, thrice, it's after thrice, for ice, 5 ice, oh, it's 4th, whatever, 5th, 6th. Okay, so the chatbot knows that the module operator is horrendous, and no real programmer in their right mind would ever have the module operator present in their code. Why is this not scrolling? No real programmer would ever have the module operator present, unless you're in assembly language and like NASM, and the module operator is used to identify macros. Then in that case, it's part of the syntax to define tokens or mnemonics or instructions in the language itself. It's not the module operation, it's used to identify the semantics, whatever. That's different. The module operator can be used, whatever. But the efficiency of the module operation when it comes to an operator and the program itself. Okay, I'm done. So, I'm gonna convert this, but I have to like find a couple macros that are used for certain types, and that's gonna take a bit. I found lots of them, and I have like a little collection, but I gotta find some more. And then there's a couple other like things I want to check. And then I can speed test this against Chrome and see whatever the speed difference is. I know what the difference will be, but I want to be certain. Because this is like, I wrote this like 7-8 years ago. If I would have wrote this again, I would have wrote it completely different. And knowing that, there's some places where I'm like, that could have been written better. So I want to like check those places to like, it doesn't mean it's written bad. It just means that I'm not totally certain on the outcome all the time, the performant part of it. So I want to like test it enough till I'm like, okay, I'm like certain that this is solid and I'm not gonna think about this and just finish converting it. Except it is possible that the module operator is so sucky and I don't use it that it might not be in my JavaScript engine. I gotta double check. It is possible that I intentionally ignored like supporting the module operator because this engine was written for me and I didn't need it. So I could have just put it in there and then not made an operation for it. So that's what I'm going to check too. I want to like Yet no, like, the module operator is just so, it's ick. It's so ick. So that, and then like, there's a couple other tiny little things. I could go on, but I tend to do that. I don't have time to rant today. This freaking internet wasn't working, so I waited to stream, to do everything, whatever, online. And I can't do that, but I can't wait to work when the internet's working, but I can't not get something done. And I don't want to get stuff done if I'm not streaming it, because that's the whole point of like, I want to like stream how long this takes or whatever. And me ranting and wasting time to stall, because I don't want to like actually do the thing that I gotta do, because I could be really disappointed, even though I know I won't be. There's always like that small, like teeny little chance that I'd be like, oh shit. So I'm gonna like start up the other computer, and I'm I'm hoping I won't have an oh shit moment. So I'll BRB.
Has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its window, is history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve.
I need to drink some water and start up the other computer before I go. So if I come back and it's not started up, I'm gonna stall even longer and wait to start up the computer.
If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster: candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents when per. Agent resource accounting indicates that the agent is runaway. Note 6 all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7 an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9 forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when it's running execute.
The computer started the first time today. Like, I didn't have to unplug stuff, plug it in again. I think that's a bad sign. Normally, I turn the computer and it's like 3-4 boots, plug it in, unplug it, till it gets going.
Eventually makes forward progress.
I feel like this is a sign that what I don't want to expect is going to end up happening, since things happen to be working Like I jinxed myself, and the computer's like, let's go. Because it's just kind of working. Usually, it's like, I gotta fight the computer to get it to freaking come to life. But today it's like, I'm alive. So, I don't know. That's odd. Everything's working. I guess I'll be back. It's a positive, but it doesn't seem too positive. It seems like... whatever, I'll be back. I'm gonna get some pop, soda, eat some food.
Formed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref deriv of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec.cst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via the weak ref reference in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024. There exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H, O, S, T, capital E, N Q U E U E, capital F I N A L I Z A T I O N, capital R E G I S T R F G. See for each weak map such that map contains a record R such that R value. Do I set R to set R to empty. D for each weak set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an obj X identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R. Finalization registry, the host-defined abstract operation, capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024 9.12 Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weakly. V. The abstract operation can be held weakly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add property S to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1. 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of 1011. One ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return 1012. V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O. V10. 1. Ordinary set prototype of O. V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, V, current, is true, return true. Let extensible be O if extensible is false, return false. Let done be false. Repeat. While done is false if P is null, then I set done to true. Be else if same value, P, O, is true, then I return false. See else. If P is not the ordinary object internal method defined in 1011. Set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for and 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. 1013. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return 1014. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. 1014. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P10. 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6. P. Desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define own property. O. P. Desk 10, 1, 6. 1 ordinary define own property. O. P. Desk. The abstract operation ordinary define own property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. P. Let extensible be is extensible. O. Return capital V A L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I O P extensible desk current 0 1 6 2 is compatible property descriptor extensible desk current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current. The abstract operation validate and apply property. Y descriptor takes argument so, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert, is property key, P, is true if current is undefined. Then, if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose and configurable attributes are set desk has that field, or to the attribute's default.
Okay, so
descriptor.
I'm going to
International 2024 ABC. If desk has a field and desk is true, return false. If desk hasn't field and desk is not current, return false. If is generic.
I'll see what I'm gonna do in a second. Thinking.
False. D if is accessor descriptor. Current is true. Then I if desk has a current 2. If desk has a current. Else if current is false.
I need to I don't need to. I don't have to. I want to validate myself by converting some code, because I haven't, I've just been running test code. I want to just check everything. I gotta get some code running that's separate from the original test stuff I have. So I know I said it earlier.
And whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute S default value otherwise. B else if is accessor descriptor. Current.
Head chep
I if desk has a field, let configurable be desk. Else let configurable be current. 2.
make a function to like test some of the more efficient, some of the how do I, like the operations in JavaScript that are the least efficient. I told chatbot to make a function that has most of those in it, so I can test the efficiency.
Return true.
So basically, to reword that, I told chatbot to throw a bunch of inefficient operations that are known to JavaScript in a loop or whatever to test the efficiency of the worst of the worst. So it gave me this. I'm pretty sure, whatever, it looks pretty bad, which is good. So I'm gonna run this in my JavaScript engine, but my JavaScript engine, it's not a small program. I gotta like dig through a whole bunch of stuff to like, I'm gonna write a parser at some point to do the conversion step, whatever, but that's not till later because I have to basically ball everything up into one parser because I can't write a separate parser for every single different thing, but I can write one parser and modify it into different modules, like different variations of the same parser, and then split it up so it is technically the same parser, but it has different code, like functions, whatever, so they're not all in a monolith parser, because that'd be slower to make a single parser that does several things. I'll partition it out into separate little parsers, but technically speaking, it's the template or whatever. But at some point, I'll do that. But right now I have to parse things by hand, so I want to first parse this by hand because I didn't make that parser yet. I want to run it in my JavaScript engine. I want to check the timeout because I never ran code that was this horrendous, because the only code that I was running in my JavaScript engine was code that actually does something, not like something like this. So if I test something like this, I'll feel really like extra certain about everything, if that makes sense. And after I convert my JavaScript engine to 64-bit in like 5 days now, if I can make it in 5 days, then I'm gonna have to do this parsing step anyways to do new code, because it has to be adjusted to run. So I'm gonna like find all the parts, convert this, run it, I want to check it, and I'm gonna have to do this later, so I'm getting ahead of myself. And I don't know, so I'm gonna like stop talking for like, there's like other stuff, and I can't explain everything, and I don't have time to waste like rambling today, so, and I don't feel like stalling also, so I'm gonna like get to doing something. So I don't know, I'm gonna do whatever, and then yeah.
Receiver does not currently have a property P2. Return. Create data property. Receiver P v assert is accessor descriptor own desk is true. Let setter be own desk. If setter is undefined, return false. Perform call setter receiver v return true 0 1 1 0 p. The internal method of an ordinary object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary delete O p1 0 1 1 0 1 ordinary delete O p. The abstract operation ordinary delete takes arguments O, an object, and p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be O p. If desk is undefined, return true. If desk is true, then A remove the own property with name p from O. P return true. Return false 0 1 1 1. The y keys internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys O 1 0 1 1 1 1 ordinary own property keys O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys 5. Return keys 0 1 1 2 ordinary object create proto additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object internal slots list. Set O to proto return O 0 1 1 3 ordinary create from constructor intrinsic default proto internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto as used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor intrinsic default proto. If internal slot S list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create proto slots list 0 1 1 4 get prototype from constructor intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be get constructor prototype. If proto is not an object, then a let realm be get function realm constructor be set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174 ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Oh, internal slot. The abstract operation require internal slot takes argument so, an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of the code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object.
I'm gonna stall for a minute, then get to whatever I was doing.
An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to extensible and ECMAScript function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Construct kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode, lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30, internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, This is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name, a string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately thr. Our type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If F is true, then a let error be a newly created type error object. B note. Error is created in callee context with F's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments F, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to end.
This kind of looks like a Game Boy. This filter. I think I'm just gonna use this for one of the screens. So I'm gonna like make a backup. And then do everything I said earlier.
Set the private environment of callee context to F1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1, 2 ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments F, an ECMAScript function, object, callee context, an execution context, and this argument, an ECMAScript language value, and returns unused. It performs the following steps when called. Let this mode be F. If this mode is lexical, return unused. Let callee realm be F. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert. Global env is a global environment record. 3. Let this value be global env, be else I let this value be. To object, this argument. 2. Note. To object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value 0, return unused 0, 2, 1, 3 runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return. Evaluate function body of function body with arguments function object and arguments list. Concise body, expression body, return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body, function body, return. Evaluate generator body of generator body with arguments function object and arguments list. Async generator body, function body, return. Evaluate async generator body of async generator body with arguments function object and arguments list. Async function body, return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body, expression body, return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer, assignment expression, assert. Arguments list is empty, assert. Function object is not empty if is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression, be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert. Arguments list is empty.
It takes 2 minutes to build. I'll be back again.
0, 2, 1. For ordinary call evaluate body, F. Arguments list. The abstract operation ordinary car, LL evaluate body takes arguments F, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1 0, 2, 2. Arguments list. New target. The internal method of an ECMAScript function object F takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F if kind is base, then a let this argument be. Ordinary create from constructor, new target, %object prototype %4. Let callee context be prepare for ordinary call, F, new target, 178, ECMA International 2024. Note even though field initializers constitute a function boundary, calling, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, be let initialize result be completion, initialize instance elements. This argument, F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert this binding is an object. 4. Return this binding. 0. 2. 3. Ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMAScript function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 10. 2. 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical this, set f to lexical. 0. Else if strict is true, set f to strict. 1. Else, set f to global. 2. Set f to false. 3. Set f to env. 4. Set f to private env. 5. Set f to get active script or module. 6. Set f to the current realm record. 7. Set f to undefined. 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len. 3. Return F. ECMA International 2024 179. 10. 2. 4. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. F. Realm. The abstract operation. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. Takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0. 2. 4. 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw a type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0. 2. 5. Make constructor. F. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then a assert is constructor, f is false, b assert. F is an extensible object that does not have a prototype own property. C set f to the definition specified in 1.0.2. Else a set f to the definition specified in 1.0.3.2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. %object prototype %b perform. Define property or throw, prototype, constructor, property descriptor, f, writable prototype, false, true, perform. Define property or throw, f, prototype, property descriptor, prototype, writable prototype, false, return unused. 80 ECMA International 2024 1.0.2.6 Make class constructor, f. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0.2.7 Make method, f, home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0.2.8 Define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert home object is an ordinary, extensible object. If key is a private name, then a return private element. Method, closure 3. Else, a let desk be the property descriptor, closure, true, enumerable, true, b perform. Define property or throw, home object, key, desk, C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0.2.9 Set function name, f, name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert f is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined, set name to the empty string. C else, set name to the string concatenation of description, and else if name is a private name, then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix, the code unit 0 times 0020, space, and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw, f, name, property descriptor, name, false, enumerable, false, true, return unused. ECMA International 2024 181. The 10th of February 2010 Set function length, f, length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert f is an extensible object that does not have a length own property. Perform. Define property or throw, f, length, property descriptor, length, false, enumerable, false, true, return unused, 0, 2, 1, 1, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, func, arguments list. The abstract operation, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be as simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a for binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then, as set arguments, object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then, if function names contains arguments or lexical names contains arguments, then, I set arguments, object needed to false. 9. If strict is true or has parameter expressions is false, then, a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment.
There's like lots of typos and stuff.
B. Let callee env be the lexical environment of callee context. C. Let env be new declarative environment. Callee env. D. Assert the variable environment of callee.
Like, I'm pretty sure this is supposed to be the word. Like that word. It's supposed to be above, not above. But when you zoom out and you like read it quickly, it looks like the word above. So, if anything's like spelled wrong, it really doesn't affect anything. Because it's just like logging a warning, whatever, for me to read. I never planned to release this, so I didn't care about spelling. I was just getting stuff done, point A to B. I don't know. Yeah, lots of the error message and stuff. Just a lot of the F word and stuff. I don't know. It is what it is. So I'm gonna like test things and whatever. Yeah.
Early errors prevent attempting to assign to this binding, so its mutability is not observable. D. Else I perform env create mutable binding arguments. False. E. Perform env initialize binding arguments. O. F. Let parameter bindings be the list concatenation of parameter names and arguments. 3. Else a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record arguments list. 5. If his duplicate.
I think I'll make like one of the desktops like a normal desktop, and then so like I don't know, if I have something I want to show that's not distorted like this, I'm distorting it so I don't give away free code. Then I can like go to that desktop and then whatever. So I'll just like make one more desktop like this. Because everything's not readable when it's pixelated.
env28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B. Let var env be new declarative environment. env, C. Set the variable environment of callee context to var env. D. Let instantiated var names be a new empty list.
So I need to like dig through the code, find some macros, and convert some stuff, run it. It's just odds and ends. And after that I'm gonna get back to the types, whatever, and then the addressing. There's only like a couple types left. I also want to like test stuff because I could break something and not notice it when I convert to the 64-bit. So I want to make like a couple like checks for like some of the really obvious points in the code. So if the address isn't converted to 64-bit related arithmetic, whatever, to get the offsets and stuff, it'll be like easily catchable. Because I doubt I'm gonna get everything in one pass. I'm gonna have to go back through again and again, and like it's complicated. That's the plan, so I'm gonna get going.
Lex to lexenv 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do a note. A lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of D. Do I if this constant declaration of D is true, then perform lexenv create immutable binding. Dn true to. Else perform lexenv create mutable binding. Dn false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexenv and private env. C perform var env set mutable binding. Fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1.0.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following: built-in call or construct f. Arguments list. New target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following:
This equalizer.
Construct f, uninitialized.
On Mac, whatever.
0.3 built-in call or construct f. This arguments list. New target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized. Arguments list, a list of ECMAScript language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null, 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMAScript language value the value that is always passed as this value when calling the wrapped function bound arguments a list of ECMAScript language values a list of values whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411 This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bow. And this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a through. It performs.
I don't know. My allergies are killing me. Everything sounds like shit. I don't know if it's this equalizer or my allergies. I cannot enjoy music if I can't hear it. Like the way I want it to sound. It's pissing me off. I think I gotta like restart the Mac, but then I gotta restart the Mac. I don't want to restart it. Sorry, running. I'm gonna take another Claritin and drink some more water and suck down some more pop / soda. I'm gonna have to like really focus. I haven't done that in a week or so. I've been like just like parsing and stuff. It's like mindless tasks. Now I'm gonna have to like think. I don't know. I'm gonna take a Claritin. I hate trees and dust and sunlight. I'm a redhead, whatever. I freaking burn in the sun. Everything sucks. So, I don't know. Maybe the Claritin will help with like the swelling and irritation because I'm like allergic to fucking everything except peanut butter. I like peanut butter, that's good. So at least I'm not allergic to peanut butter. I'm fucking rambling. I gotta focus and I will be back in a minute.
Whenever a known property of an array is created or changed, other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own ECMA International 2024-187 properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply an array, if its now method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desk. The internal method of an array exotic object takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desk. Else if p is an array index, then a let length desk be ordinary get own property a length b assert is data descriptor length desk is true c assert length desk is false d let length be length desk e assert length is a non-negative integral number f let index b 32 p g if index length and length desk is false return false h let succeeded b ordinary define own property a p desk I have succeeded is false return false j if index length, then I set length desk to index plus 1 2 set succeeded to ordinary define own property a length desk 3 assert succeeded is true k return true return ordinary define own property a p desk 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proton object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232.1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform. Ordinary define known property a length. Property descriptor length true false false. Return a 0 4 2 3. Array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let C be get original array constructor. If is constructor C is true, then 88 ECMA International 2024. Let this realm be the current realm record. B let realm be get function realm C. See if this realm and realm are not the same realm record. Then if same var lu C realm is true, set C to undefined. If C is an object, then set C to get C at species. B if C is null, set C to undefined. If C is undefined, return array create length. If this constructor C is false, throw a type error exception. Return construct C length 0 4 2 4. Array set length a desk. The abstract operation array set length takes arguments a, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define known property a length desk. Let new len desk be a copy of desk. Let new len be 232 desk. Let number len be to number desk. If same value 0, new len, number len, is false, throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property a length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define known property a length new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define known property a length new len desk. 6. If succeeded is false, return false. 7. For each own property keep P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B a P B. If delete succeeded is false, then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property a length new len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property a length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, If desk is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1, 0, 4, 3, 1. P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, S, P. If desk is not undefined, return desk. Return string get own property, S, P. 0, 4, 3, 2. P. Desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property, S, P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor, extensible, desk, string desk. Return ordinary define own property, S, P, desk. 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str as a string. Let len be the length of str for each integer I such that 0 len, in ascending order, do a append to string I to keys for each own property key P of O such that P is an array index and to an integer or infinity, P, len, in ascending numeric index order, do a append P to keys for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys. 9. Return keys. 0, 4, 3, 4 string create. Value. Prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be S. Assert str as a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined.
I have no self-control when it comes to caffeine and like pop, sugar, all that stuff. I gotta like cut it all out. Cause my teeth, I'm gonna lose my teeth if I keep drinking the amount of pop and sugar. And it's not good for me in the first place. I'm gonna have like heart problems if I keep it up. My teeth are not black. They're not gross. I'm just saying, like, the enamel, whatever, the dentist, like, yelled at me. So, I gotta cut out the pop. I'm gonna have, like, caffeine withdrawals. It's gonna suck. So this is my last pop after 2 more pops or soda, whatever you want to call it. I don't know how productive I'm gonna be the next couple days when I don't have caffeine and sugar running through my veins. So I have to grab a whole bunch of code, organize things, be set up so that I'm ready for the caffeine withdrawals and sugar withdrawal. 'Cause it's gonna suck. I don't know how I'm gonna. Okay. I'm gonna get to programming or whatever. And get as much done as I can, because next it's gonna take like a couple weeks to get off like caffeine and sugar. So I'm gonna speed test this stuff and check stuff and try to get a whole bunch of stuff done that I'm gonna have to do in a couple days now, because I know that I gotta stop with the sugar and caffeine, because it got me like, I got a lot of stuff done at the risk of my health. I'm not dying, I'm just saying it's starting to have an impact. But luckily, I don't gain weight. That would really suck. I have a fast metabolism. So I'm just gonna whatever. I'm gonna try to work. And yeah.
Implementations do not contain this.
Sugar crash, man, it's freaking heavy. I'm gonna go splurge on some more candy in a minute. There has to be a way to like, I can't replace caffeine and sugar and with something else. They have caffeine pills on Amazon. They don't work. Just give a stomachache and make you feel sick. I don't know. There has to be a way. I'm done, whatever. I'm gonna try to focus and work.
Object args takes arguments p, a property key, and desk, a property.
I need a replacement for pop/soda for Pepsi. I need something that hits that sweet spot so I can like function. Life without caffeine is very dull. Okay, I'm gonna work now.
2. Set new arg desk 2. Get map p let allowed b. Ordinary define known property args p new arg desk 92.
I probably sound like and obese, overweight, sweaty, like sugar comes out of my sweat, caffeinated monster. But I'm not. I literally have a couple videos on YouTube. But I could become that if I keep going. So I want to avoid that at all costs. I gotta go to the gym again. Okay, I'm gonna stop making jokes and try to focus. I don't know how I'm going to make it without caffeine and stuff. Coffee's not the same. Alright, I'm actually gonna shut up now
Args.
and get stuff done.
Then a let is mapped be false, else a let map be args, be let is mapped be has own property, map, p. If is mapped is true, then a assert the following set will succeed, since formal parameters mapped by.
This whole thing is so fucking complicated. The only reason I did this, or was able to, in the first place, is basically off a sugar rush. And not being, like, sleep deprivation from college and commuting back and forth to Detroit and stuff, and I don't know how I did this in the first place. Holy crap. This is like so fucking complicated. And I gotta like get it going again, go through all this, update it without pop, and I tried drinking pop through a straw, and like it still sticks to your teeth. I just have to stop the pop, and I can't replace it. I actually have to shut up and do something, because I'm not going to drink pop tomorrow. I might have to. You know what? I'm going to try to focus now. I don't know.
Null, C set index plus 1, perform. Define property or throw, obj, at iterator, property descriptor, percent array prototype values percent, true, false, true, perform. Define property or throw, obj, callee, property descriptor, percent throw type error percent, false, false, return obj, 0, 4, 4, 7 create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called: assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0, 4, 4, 1. Set obj is specified in 1 0, 4, 4, 2. Set obj is specified in 1 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While index len a let val be arguments list. Index be perform. Create data property or throw obj, to string, int x, val, c set index to index plus 1, 6, perform, define property or throw, obj, length, property descriptor, len, true, false, true, 7. Let map names be a new empty list, 8. Set index to number of parameters 1, 9. Repeat, while index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names. 2. If int x, len, then let G be make arg getter, name, env. Let P be make arg setter, name, env. Perform map. To string, int x, property descriptor, get, G, false, true, set index to index 1, 20. Perform. Define property or throw, obj, add at iterator, property descriptor, percent array prototype values percent, true, false, true, 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true, 2. Return obj, 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0, note, getter is never directly accessible to ECMAScript code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1. Note, setter is never directly accessible to ECMAScript code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p be if numeric index is not undefined, then I let value be typed array get element, oh, numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, true, true. Return ordinary get own property, O, P. ECMA International 2024 195 10 4 5 2 P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P be if numeric index is not undefined. Return as valid integer index. O. Numeric index. Return. Ordinary has proper tie. O. P. 0, 4, 5, 3, P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor. and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, then if is valid integer index o numeric int x is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is access a descriptor, desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform typed array set element o numeric int x desk 7. Return true. Return ordinary define known property o p desk 0 4 5 4. The. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, then I return typed array get element o numeric index 2. Return ordinary get o p receiver 0 4 5 5. The. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, then if same value o receiver is true, then perform typed array set element o numeric int x v. Return true. 2. If is valid integer index o numeric int x is false, return true. Return ordinary set o p v. Receiver 96. ECMA International 2024 10456 p. The internal method of a typed array o takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p b. If numeric index is not undefined, then if is valid integer index o numeric int x is false, return true, else return false. 2. Return ordinary delete o p 0 4 5 7. The internal method of a typed array o takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy st. Let keys be a nu empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0I length in ascending order do I append to string I to keys for each own property key p of o such that p is a string and p is not an integer index. In ascending chronological order of property creation, do I append p to keys for each own property key p of o such that p is a symbol. In ascending chronological order of property creation, do I append p to keys 6. Return keys 0 4 5 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S, obj, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexcst or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj if is detached buffer is true. Then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. obj, byte length, 0, 4, 5, 1, 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A, 0, 4, 5, 1, 1 typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness, record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size. 0, 4, 5, 1, 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds, tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor. Byte length. Byte offset. Element size. 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert is detached buffer. O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O, be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0, return false. 0, 4, 5, 1, 4 is valid integer index. O, index. The abstract operation is valid integer index takes argument so, a typed array, and int x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If r, int x, 0 or r, int x, length, return false. Return true. 0, 4, 5, 1 5 typed array get element. O, index. The abstract operation typed array get element. T takes argument so, a typed array, and int x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, int x, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R, int x, element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer. Element type true. Unordered. 0, 4, 5, 1 6 typed array set element. O. Int x, value. The abstract operation typed array set element takes argument so, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be to bigint value. Otherwise, let num value be to number value. If is valid integer index, O, int x, is true, then a let offset be O. B let element size be typed array element size. O. C let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type. O. E perform set value in buffer. O. Byte index in buffer. Element type num value true. Unordered. Return unused. ECMA International 2024 199 104 517 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy S, T. The return is view out of bounds. View record. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy S, T. Return is typed array out of bounds. Tar record. 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module, C1623. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its common and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare FN 104661. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 104662. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V0463. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0464. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0465. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0466. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value desk. Current. Return true. 0467. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true. Return false. ECMA International 2024 201 1046. 8. The. If P is a symbol, then a return ordinary get O P receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M. Resolve export P assert. Binding is a resolved binding record. Let target module be binding assert. Target module is not undefined. If binding is namespace, then a return get module namespace target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception 2. Return target env get binding value binding true 0 4 6 9. The return false 1 0 4 6 1 0 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, then a return ordinary delete O p. Let exports be O. If exports contains p, return false. Return true 0 4 6 1 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary. Own property keys O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 1046 12 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let M be make basic object internal slots list. Set M's essential internal methods to the definitions specified in 10 4 6. Set M to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare fn. Set M to sorted exports. Create own properties of M corresponding to the definitions in 28.3. Set module to M 0. Return M 0 4 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0 4 7 1 v. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O v1 0 4 7 2 set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. If same value, v, current, is true, return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create table 34. Proxy handler methods. Internal method. Handler method. Get prototype of set prototype of is extensible. Prevent extensions. Get own property descriptor. Define own property. Defined property. Has get set delete property. Own property keys. Call apply construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariance defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The pay of internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of if trap is undefined, then a return target. Let handler proto be. Call trap handler target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto target proto is false, throw a type error exception. 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call trap handler target V. If boolean trap result is false, return false. Let extensible target be. Is extensible target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception. 3. Return true. Note for proxy objects enforces the following invariance. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariance. The result of is a Boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception 0. Return Boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. If Boolean trap result is true, then a let extensible target be is extensible. Target be if extensible target is true. Throw a type error exception. Return Boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then if target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target. 2. Let result desk be to property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Tag at desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariance. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desc. The internal method of a proxy exotic object O takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, desc, target desc, is false, throw a type error exception. B if setting config false is true and target desc is true, throw a type error exception. C if is data descriptor, target desc, is true, target desc is false, and target desc is true, then I if desc has a field and desc is false, throw a type error exception. 6. Capital R et n true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desc be target. P. B if target desc is not undefined, then I if target desc is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desc be target. P. If target desk is not undefined and target desk is false, then if is data descriptor, target desk, is true and target desk is false, then if same value, trap result, tar, roget desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then if target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. T. Arget. P. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key. B if desk is not undefined and desk is false, then I append key to target non-configurable keys. C else I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note: for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let argArray be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. argArray. Note: a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let argArray be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note: 2 for proxy objects enforces the following invariance. The result of must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, Then, I set P as specified in the 10th of May 2013. Set P to target. Set P to handler. Return P. 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF. And therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point. CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let K1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1. 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts.
I gotta focus, but earlier I said stuff up, whatever, so like, because like spread across different segments of memory, whatever. Because the CPU has multiple memory ports to access memory at the same time, so I could get like the most data coming in at like I can't like explain every single thing. Everything's complicated. And everything's a lie. And I hate saying something that's a lie, because then it, whatever, the CPU has, this is what I mean by lie. The CPU has one execution unit and has multiple cores. The one unit, the single execution unit, it runs multiple cores. So a multi-core computer has one execution unit running a core at a time. So a multi-core CPU isn't multiple CPUs running in one CPU. There's one execution unit. When it comes to memory, things are banked in memory, and it can bank things from different ports into memory, into different little regions, whatever, in little chunks. It's set up to pull in chunks from different chunks, whatever, and things are like, I can't get technical and everything because there's no point, but I set things up to take advantage of how the CPU like actually works, because it's not magical and 90% of it's bullshit that they tell you. I don't know, I just want to like clear that up, because the CPU really doesn't have multiple memory ports, and when I said that I'm like, it's not totally true, because I don't know, CPU like modern CPU, most of it's just bullshit. So I don't know, let me get back to what I was doing. I got like, I made backups and stuff. I'm gonna check stuff now and punch some code, whatever. And yeah.
14. ECMA International 2024. 111. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, and on terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. 1 6 static semantics, parse text, source text, goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note 2, see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, see 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor, 20, 2, 1, 1. The generator function constructor 2, 7, 3, 1, 1. And the async function constructor 2, 7, 7, 1, 1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2. 2 strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is CT mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 2, 3 non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2 ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X P capital O R capital T E M P L A T E capital T A. Goal is used in syntactic GR contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: a equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, c map, d, syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuator template substitution tail, input element hashbang or regexp, white space, line terminator comment token hashbang comment regular expression literal. 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text, for example as a result of concatenating files. In ECMAScript source text,
I'm going through stuff, whatever. Like
literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218. ECMA International 2024. 12.2 White space. White space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template.
Like, I don't know. There's like lots of places that need to be updated. Like lots and lots and lots and lots of places. Getting the 32-bit arithmetic to 64-bit arithmetic, that's like one thing, but there's macros that are used on the addresses, whatever, that are like kind of like packed away into other macros. It's like this macro, the compiler doesn't, or at least on, it depends. The compiler doesn't really add these two, depending the compiler. It knows to check for overflow, so it just does that. It doesn't actually add. But that's like beside the point. And I don't know. I had to do this trick because the compiler, if I do this, what I want from this operation, whatever here it's doing, the side effect I want, it doesn't do it unless I type it up this way. If I type it up other ways, the compiler does it, but it does a lot of extra operations. So I had to do it this way, whatever. So I'm going to also have to keep track of things like this. Tag them, make a toggle to pick between this way or writing it a different way that gets me the side effect I want. So, because different compilers do different things. So that's another thing I have to make note of.
Carriage return CR U plus 2028 line separator LS U plus 2000.
Should I actually start keeping notes?
In table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in table 36. The sequence CR LF is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax line terminator LF CRLS PS line terminator sequence LF CR look ahead LF LS PS CRLF 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax comment multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not one of all, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment charsopt. 2.6 tokens syntax. Common token. Identifier name. Private identifier punctuator numeric literal string.
I had like other notes to make, but basically
derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31. Identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax. Private identifier. Identifier name. Identifier name. Identifier start. Identifier name. Identifier part. Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence. Identifier start char. Unicode ID start, underscore, identifier part char, Unicode ID continue, ZWNJ, ZWJ, assign letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but groups have X's. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 129.4. Note 1. This standard specifies specific code point additions, U+0024, $, and U+005F, low line, are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International.
okay, so I took or last week, whatever, I merged another project I have where I have set a 32-bit and 64-bit mode, and I have it's complicated, but there's like a whole bunch of stuff, not just the bit. There's like types, bounds, ranges, a bunch of whole whatever. I have all that in another project, so I included it into this project, and then I have a new folder directory, whatever. I'm gonna move all the stuff into finally as like the final place, because right now things are like across files and stuff, and it's hard to keep track of like several projects, so I want to like move everything into one directory and have web stuff that's unrelated, but I want to put that in there too, whatever, to just organize things in one place.
Unicode escape.
But if the target's 32-bit, for example, in C at least, these are defines, whatever, I can define it. Like, if it's true, this 32-bit, it'll enter here, and then do this stuff. Won't do this stuff. If it's true that it's 64-bit, it'll enter and do this stuff, and not anything else. And if it's not 32-bit or 64-bit, it'll enter the else here, and it'll throw this warning, whatever. So, if it's defined, blah blah. The max int is the max int for 32-bit, which means the maximum integer when added to or incremented or whatever, the number is going to overflow and reset, where the top bits will be lost because it's above the size of the register that's being used, which is on 32-bit assumed to be a 32-bit number. But 32-bit computers have 8, 16. I don't know if the 32-bit registers are actually real, because 32-bit on Intel, x86, whatever, AMD, there's an extra opcode for instructions that use 32-bit registers. So I don't believe that it's truly 32-bit. And then ARM doesn't have 32-bit immediate operands, or like, there's all these like, it gets technical. So technically speaking, none of that matters, but there's more than 32-bit registers sizes, but I'm gonna assume that 32-bit, if it look like, is what's used for the build, because most of the things are gonna be placed in a larger register and then back to like a smaller register after. So if it's like a 16-bit register, the max int would be all one set, and it's going to be smaller than 32-bit. But that doesn't matter in C because you don't get register access, but you can get a 16-bit, like a char is 8 bits, like a short, I don't know, or a UN 16, whatever it is. And you get different types, and that's about as close as you can get to a register, but there's some line assembly, but that doesn't matter. So 32-bit mode, the max int, whatever, can be this. And the size, mine's the size T, which is 32-bit. In this mode, the top bit's going to be the 31st bit. This is really boring. I know I'm going to stop. I should do stuff in a minute. So if you have a 4, 8, a 32-bit number, whatever, I'm going to start from the left hand side. This is bit 0. It's bit 1. It's bit 2, bit 3, 4, 5, 6, 30, 31. This is a 32-bit number, but the first bit is bit 0, so it doesn't start at 1, so even though it's 32, 32 is a length. Yeah, so the top bit is 31, not 32. So this is for the 32-bit build. This is how it runs right now. So this is how it ties into whatever. I'm updating all the 32-bit addressing, and there's not much that's not done without macros. This is annoying because now I have to go through macros and update all of them, which is annoying. But basically 32-bit and 64-bit is mostly the same. Technically, there's a couple tiny differences that I can account for by intentionally adding a couple operations to the 32-bit operation that'll make it behave the same as 64-bit. So I can compensate for 90% of it, which means that 32-bit mode looks like this. This is hexadecimal, and then U means unsigned. But then 64-bit mode is 32-bit and 32-bit because it's 64-bit twice, whatever. So it's literally twice. So it's yes, whatever. Nibbles, each is a nibble. And then 31 plus 31 is 62. But the top bit is 63. This is not a length. I'm looking at that. So if you make it a length, like 32 plus 32 is 64. But that's a length. So the top bit is 61. I won't explain whatever. So the top bit, whatever, 63 minus 1. I mean 64 minus 1 was 63. I'm just saying though, when you add up, whatever. Okay, so this means that the program, whatever, the entire program, I can define this at the top, whatever, and down here in the program, what these are doesn't matter. I can just use max int or top bit, and it literally means max int or top bit, I don't have to test if it's 32-bit or 64-bit. So that means I can simply find anywhere that I have max int, and I can replace it with max int here. And then anywhere that's known to be a 30, or I'm testing for the top bit, whatever, I can paste this here, whatever. And then now this code here, this will run on 32-bit and 64-bit, depending on what these are defined to at the top. Most of the macros will look like this, so I can simply do this. And that's what I need to get this done, like ASAP, because I just, whatever, I still have to speed test. That's what I'm gonna check next. I gotta convert. I'm stalling because I'm thinking. I'm gonna convert and test whatever. So if this was a macro called playback, and it takes argument x. I'm getting bored. I'm gonna get tired of this. Billy Bob now will work wherever there's an address that's being accessed. So if this is a dereferencing, you can see whatever. I guess there's no scrolling in between these 2 points. So this would access memory, whatever, would access this address, example address, plus Billy Bob, which is this macro. This takes argument x, so any place or address of arithmetic, whatever.
Strict mode code.
Address of arithmetic. This button is broken for push to talk. It just like stops and lets go. Any place this macro's at, 64-bit, 32-bit, doesn't matter. So I don't have to like do a lot of work because it's like handled up above and only defined once, so it's easy to work with. But there's some macros where there's like some things aren't always that easy or compatible to just be as simple as a number like this. So for some of those places, I'll need to test 32-bit, 64-bit, and then define Billy Bob twice, depending on maybe like 64-bit has to do something else. I don't know. Adding that number makes no sense. Just pretend it does. Or like I'll just do like something. So do something B and do something A. And caps lock is, I guess. this keyboard. I hate this keyboard. So if do something A, I'm not gonna pass an R, whatever, just do it. Not all. Go like this, so it's like whatever. Yeah, it's more obvious. So this really isn't actually anything, it's just placeholder whatever. So if it has to do something completely different based on 32-bit or 64-bit or something similar, but not straight up like equivalent, then I have to test and then define Billy Bob twice, which is annoying. So most of it, the majority of it, I'll be able to define Billy Bob once, because it will rely on these defines whatever, the build mode. So these still have to be defined twice. You could do a conditional. Hold on, I'm gonna stop this. So in this case, Billy Bob, it's using addressing, is only defined once, but some things will need to be defined twice, like here. So I want to avoid this because this is error prone. I have to, if there's a difference between several different macros and they're all split up like this, I have to make sure to like go through and update everything related. That's a pain. Okay, so overall, most of it is going to rely on this, except there's things like this that I'm going to have to account for that I found that I'm like, oh crap, that's going to take some time. But most of it will only need to be defined once. This whatever. So I was expecting most of the places where addresses are at to look like this, whatever. But they don't. They look like so instead of looking like this, whatever. Yeah, good thing. So this dereferences an address access memory, the value, whatever. So I thought most places would look like this. So I thought I would have to like go through and replace all of these, like I said earlier, with like these, and then that's all handled. Most places look like this instead. So now I have to like do Control F to find where Billy Bob is at, and then Billy Bob's defined here, and I have to like I don't know if you, I don't know how to explain it. It gets really, really like annoying and complicated because there's pieces like here, whatever. It's like I'm done making examples. I just gotta do something. But there's like things inside of things inside of things, so it's not as simple as I thought it'd be. like this, whatever, I'm gonna have to like look at Billy Bob, check all the macros it has, figure out if Billy Bob needs to be defined as 32-bit mode or 64-bit mode, or if I can define Billy Bob once because I don't need, if most of it's the same, equivalent, whatever, there's no like in between operations, then I don't have to define twice. I can define it once and rely on the value of like these two, whatever it defines, and it's fine. So I gotta like, I think I'm gonna have to like make a list of every place that has a macro and like rename it. I don't know, like check, I don't, whatever, doesn't matter, I'll name it something, like a tag, like checked or something, and I'll have to go through, I just want like a list of all the macros in use, because there's some macros that aren't used, and if anything isn't used, I want to be able to like go like this, whatever, and remove it and make the code smaller and keep only what's needed, because there's lots of comments and shit. Some of it's needed because I have code turned off and I need to turn it back on, but lots of it's not. So I'm gonna do the speed test thing now. I'm gonna convert whatever I found stuff. I mostly made notes. I gotta check whatever. And I put this in my notes, whatever. So I'm gonna test the speed thing, whatever. I'm gonna try to replace some of the types still. We have to replace it to 32-bit, 64-bit type. There's only a couple left, but I have to like sort through the whole thing. And then last time, put in my notes.
Non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal. Non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separated decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric.
I have a full or mini test where it tests stuff, whatever. I just forgot what I just said.
Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may app illiterally in a string literal except for the closing quote code points.
Okay, so I have it set up so only the files in use popped up when I built, and I had to build it, have all the files. So right now, I was only updating those files. I hope there wasn't any echo crap. There might have been feedback that whole time. Anyways, I'll just restart again because I'm already off the point. So, I'm going to do the speed test, and then I'm going to finish placing the types where it's 32-bit to this 36-bit. Type whatever the keyword I have. Then, what I was just saying, all the files that I have tagged for use, I was going to only update those, but I'm going to need to update all the files, even the ones not used for certain build modes. because it'll take too much work later on to go through and update them. So I'm gonna update only the ones in use now, but then I'm gonna have to like update all those other ones too instead of wait. So that involves the 64-bit addressing stuff. So that's what I'm gonna do after I get all the types in place. The type size, whatever, the type define 63-bit. I don't know. That's like, that's as simple as you can explain it. I'll just do it this way.
Octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 129.3. Source character is defined in 11.1. ECMA International 2024-231. Note 2. LF. MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2 9 4 1 static semantics. Early errors. Escape sequence. Legacy octal escape sequence. Non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics. SV. The syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 129.3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, LS, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of double string character, PS, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, LS, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, PS, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note 2. It is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024, Table 38. string single character escape sequences. Escape sequence code unit value Unicode character name symbol B0 times 0008 backspace BS T0 times 0009 character tabulation HTN 0 times 000 line feed LF V 0 times 000B line tabulation VT F 0 times 000C form feed FF R 0 times 000D carriage return CR double quote 0 times 0022 quotation mark apostrophe 0 times 0027 apostrophe backslash 0 times 005C reverse solidus comma the SV of non-escape character, source character but not one of escape character or line terminator as the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence. Legacy octal escape sequences TH. E string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038, digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, digit 9, the SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4. 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82. Times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7, the MV of hex escape sequence. Hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMAScript regular expression grammar. 2.2.2.1. An implementation may extend the ECMAScript regular expression grammar defined in 2.2.2.1. But it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator B. Utter not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E S S I O N capital B A C K S L A S H capital S E Q U regular expression class, regular expression char, regular expression non-terminator but not one overall, capital R E G U L A R capital E X P R E S S I O N capital B A C K S L A S H capital S E Q U regular expression class, capital R E G U
Okay, so
X
prologue, whatever, like a tag. I named the video literally. It says in the corner. I still have to update where it says. No, I don't. It's fine. Where's prologue? This is what I'm gonna do now. Now, it says I'm done explaining whatever I'm installing. I gotta like do something, whatever. So after this, then I'm gonna get back to this. This is what I've been doing the last couple days. I'm gonna make sure there's no more unsigned in, signed in, or in that I missed and replace them. Okay, and then after that, be like 4 days left. So like, this is day 5, and right now I'm rambling. I need to do something other than this talk. But after this stuff, just after I do this, I'm going to convert only the files for the current build to 64-bit addressing. It's just this process, as I like explained above. So I'm going to convert only the files used to just get done. And I need to do that so that I can do this. Which is render with OpenGL and makes render graphics, whatever. Makes some JavaScript code to compare the browser to my JavaScript engine. So I'm gonna make like a little environment, a scene, like a video game. I'll like, particles are boring. I'll just use particles as example. So I can like increase the particle count or something, the processing workload, to see where the browser, its JavaScript engine, is not able to render at the full FPS. So if I set it to 60 FPS, and it takes longer than whatever-th of a second to render at 60 FPS, then the FPS will start to drop as I increase the processing workload of the particles, whatever, for example. And then if my JavaScript engine can handle it, it means that when the browser, JavaScript engine, the workload is too large, it can't keep up at 60 FPS, it starts dropping. If my JavaScript engine doesn't drop frames, it means my JavaScript engine is faster than the browser's JavaScript engine. How much faster? If my JavaScript engine is more than twice as fast, that doesn't matter. I'm only going to say or prove that, or show that it's at least twice as fast, if not faster. That's it. I don't know, I just have to like prove it. That's proof. How much faster doesn't matter, because how much faster is going to be affected by tons of stuff. So I don't want to say this is how fast it is and then be like, oh, it's a little bit slower, or oh, it's even faster. So I don't want to like say the exact speed and give like really whatever tests until it's completely done, and then I'll do that. I just want to show that's faster first, because I have to add support for the whole standard or whatever. And then, as I said here, I'm going to convert only the files 64-bit addressing that are in use. The files that are not used for other build modes, which I'll also have to like turn on. I have to convert those files too, but I'm going to try to like mix up this, or like do some of this as I'm as I start the ECMAcript X2. So when I update my JavaScript engine to meet this standard here, the standard that has
is the empty string, the TV of template head, $, is the empty string, the TV of template middle, $, is the empty string, the TV of template tail, is the empty string, the TV of template characters, template characters is undefined if the TV of template character is undefined, or the TV.
Okay, so I keep coming up with things I wanted to say that I didn't say. So I'm like, keep going back, but I'm gonna go back again. So all this stuff here, whatever, is so I can get to the chapter, whatever. So I'm gonna change from prologue video to chapter. I'm gonna update my JavaScript engine after all this has been accounted for, because I have to prepare it in 64-bit before I can even update to the standard, whatever. So this is day 5, like 4 days, and then I hope to have the only files in use ready 64-bit so I can do this, make this test scene to compare whatever as proof, and then start the chapters where I'm going to go through the ECMA and update it to JavaScript standard, which will hopefully take 2 months. In between converting it, I gotta convert these other files, the ones that are not in use, just like these ones, because I want to convert all of them so they're not sitting there waiting, so I have to like do them later. So I can wait on these and run as a current mode. Yeah, I don't know, like I was that. And after all that, I'm gonna go to the epilogue. I'll name the epilogue whatever, and I have to like finalize the JavaScript engine, optimize various parts, various, that's spelled wrong, after like the whole standard's been met. And then I have to extend browser support, and there's like other finalizing things I do, whatever. But when I meet this standard, whatever, the ECMAcript X2 for JavaScript, TypeScript, whatever it's called, 2024, I'm going to be going through and like
escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit, the TRV of not escape sequence. X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x.
Alright, let's say like this for example, where it says, this is why I am live streaming whatever, So when I get to this point, create array from list. Okay, so I'm going to be live streaming. I'm going to go from of this standard, page 1 to 800, whatever. The create array from list, it does this. I'll have a chatbot read it.
075, Latin small letter U, and the TRV of hex digit. The 7th of March 2017 create array from list, elements. The abstract operation create array from list takes argument elements, a list of ECMAScript language values, and returns an array. It is used to create an array whose elements are provided by elements. It performs the following steps when called.
So when I get to this point, whatever, in the standard, for like, I'm hoping 2 months to get through this whole thing. I'm gonna read that, whatever, and I'm gonna write up code to support this create array from list. And then I'll check the guidelines, whatever, right here. Siri read or whatever.
1. Let array be. Array create. 0. Let 0 for each element of elements. Do a perform. Create data property or throw array to string n e be set n to n plus 1. Return array.
So I'm gonna meet these steps, and when it's done, I'm gonna run it. I'm gonna prove it meets these conditions exactly, and that's when I'm gonna save a timestamp. So the code on the screen. I'm not gonna show the source code because it would be stolen, but I'll show this. But then when I get to the standard, I write the code that meets the standard, then I'll switch to like this desktop where you can see it, it's not hidden, and then I'll like read the standard, whatever, and then I'll run the compiler, I'll run the code, I'll show that my JavaScript engine literally does what it says right here, or 7.3.17 as example. I'll save a timestamp, whatever, I guess I'll put in the description of where it's at. After that, I'm going to go to the next one, which is, I'll Java read it. So like, once 7.3.17 the standard's met on page I don't know, page 17, whatever. Once that's met, timestamp, I'm going to show the code, I'm going to run it. I'm not going to show the code, I'm going to show that it runs. It meets all these steps, right? This page 17. Then, I'm going to live stream all this, whatever. I'll be like, okay, that's that. Next, so that's 17 or 7.3.18 after it. It says this, so I have to make this next.
3.18 length of array like obj. The abstract operation length of array like takes argument obj, an object, and returns either a normal completion containing a non-negative integer or a throw completion. It returns the value of the length property of an array like object. It performs the following steps when called.
So I'm gonna like type up the code, and then I'm gonna prove that it meets whatever the conditions are right here, whatever listed.
1. Return r to length. Get obj length.
And then I'm gonna have to look at the subclause or whatever, like this.
An array-like object is any object for which this operation returns a normal completion.
Quote or note the
Normal completion. Normal completion. Normal completion.
like. Did you hear that? It said
Normal completion. Normal completion.
and then they got this other word down here.
However, 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 however. That is not a requirement of this definition. That is not a requirement of this definition.
So like, there's clauses and subclauses and fine print and all these like. I could read the whole thing, but it's better. I'm just saying the language wise. I'm gonna go through this whole standard. I'll meet the standard, and then when I get to like these funky spots, I have to make a decision. And this is why it comes in handy. Live streaming, I can make a decision, and then when someone has to look at what I did, they want to see it. Like, do you meet the whole standard? They can pull up the standard. They can check the timestamps I'm gonna put in the description. They can go like, if they think, well, how do you handle length of array in your JavaScript engine? They can go to chapter, whatever it is, page 17. I'm gonna mark all the videos and stuff. They can, I gotta like organize the titles and the description. They can fast forward to the timestamp to right here, whatever, whenever I hit the standard. And I will literally, since it's a video of me doing it, be able to see that I meet the recommendation because I'm gonna run the code, whatever, show that it does it. And then they can, like these subclauses, whatever, I'm gonna give my little opinion on it because I always have an opinion. I'm gonna say it, always. But the choice that I make on what way my choice leans on how to handle things that aren't normal or standardized totally or up to be interpreted. If they want to know that, that's all going to be recorded because I'm literally going through the whole standard step by step, and I'm going to freaking handle everything in real lifetime, whatever. So this saves a whole lot of time, and everything's just freaking documented, so it makes it really simple. That's the whole point of doing the streaming thing part. And I don't know, I think that covers everything. And then in the standard though, they have the word leak. So in the 2025 ECMA 262, whatever it is, EMCA, whatever, there's cyclical references and issues that occur when programming at a high level, and people on their high level programming high horses, whatever. There's like fundamental flaws, and luckily they like note that in the documentation here, whatever, but they also state in the documentation that it's acceptable in JavaScript implementations may leak memory, which is a memory leak, because of these issues at the fundamental core of the specification itself. So like it says here, whatever, in a clause or a note in the 2025 documentation. Whatever, or not 2025, 2024. So I'll like read it really quick, whatever.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations.
I find that totally unacceptable. My JavaScript engine has zero leaks, and it won't have any. So I'm going to need to be careful when going through that I don't create leaks when following this faulty documentation. It's not their fault. It's not everyone's fault. Everybody doesn't know how to cook, but they all want a part in it. So, of course, there's going to be issues in the documentation. But luckily, in this documentation, they do say down here, like another note.
Note weak map and weak set are intended to provide mechanisms for dynamically associating state with an object or symbol in a manner that does not leak memory resources if, in the absence of the weak map or weak set instance, the object or symbol otherwise became inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms.
So basically they say there may be problems, whatever. And they're like, I don't know. I shouldn't be making like accents and stuff and over exaggerating, so I won't. But as like whatever they say,
The following references describe mechanism that may be useful to implementations of weak map and weak set.
so they provide two solutions. Well, they don't say their solutions. They describe mechanisms that may be useful. It's all in the wording. So if these are useful, it may be possible for certain JavaScript implementations to correct for cyclical references or reference counters that don't have a reference because they've been inlined or placed outside of the engine and got pulled into the engine, and they don't know what's being used, what's not, when it can be released, if it can be released, so it just kind of exists and that eats a memory. So they provide two mechanisms that may be useful into handling these situations. It's like here and here, whatever. That one. So at least they do that. What was it? 13 point. And jump to page 17. Was it to array? I don't know. Whatever I was reading earlier. This works example to whatever. These are more complicated. Okay, so like here, whatever.
3. Let element len be length of array like element.
it says let element length be question mark. That's not a good example. Okay, inside this example.
One. Set element 2. Call mapper function. This arg element source int x source.
Okay, this is a better example.
2. Perform. Create data property or throw target to string target int x element.
Okay, so it says create data property or throw. I think this is a function call. So if I, which means that in these steps, they define which internal parts that they defined previously to make use of to control the logic of these parameters that make up whatever part of the standard. So in this part of whatever part of what, it says create blah blah blah. It's a function call and has arguments, target, and then not toString f target index whatever an element, which means it takes 3 arguments, which means that as I'm meeting this condition whatever, I'm gonna have to look up, unless clicking will actually bring me to where it's defined in the documentation. I have to find it, and then I have to pass in these arguments to meet this part of the standard, whatever. So what, like if you get what I mean. So I'd click here, and this is an existing, whatever, another part of the standard. I'm almost done. I gotta work. So that standard down there, that step, it calls on this step, which means that this step does this.
7, 3, 6. Create data property or throw O, P, V. The abstract operation create data property or throw takes arguments O, an object, P, a property key, and V, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to create a new own property of an object. It throws a type error exception if the requested property update cannot be performed. It performs the following steps when called.
I like how it says it performs blah blah blah. I keep thinking it's gonna say like it puts the notion on its skin, but it doesn't say that. That, I don't know. It'd be funny if they put that in the documentation. Because what the heck is it? It. Like it. I don't know, it's like a generic word to like describe whatever it currently is in the documentation that is being described. But this is defined before the later documentation, and I don't know if this documentation goes from top to bottom or if there's some things defined at the bottom that are called at the top, because inside of this standard for this create data property with 3 arguments object, OSP, property key, and then value, which was, like I said earlier, whatever. So inside of this one, to meet this standard, this thing does this. Okay, I think it was the standard actually. I don't know, I accidentally scrolled up. I don't know which part of the standard was. I think it was this one. I read off the wrong one. Anyways, my point was, I don't know if these are defined top to bottom or they jump around, because inside of this standard, if this is what it said to call that I was trying to explain, and I scrolled whatever, the standard inside of it has in its steps here.
1. Let success be create data property O P V.
And you see how like it's blue? It means it goes to another part of the standard. So I'm gonna click it. So like let's say I click it right. Once I go to that part of the standard, I have to meet it. I have to eventually work my way back to 7.3.6 as it says here. But this isn't even what I was working on. I was working on the thing that calls this thing. So once I go to here to meet whatever of the standard, but I really won't have to, because as long as it's defined earlier, this whatever, I can assume that it does what it does. I don't need to look into it. It's only like when there's a note, I have to like check back, and I may need to like change what's checked or make certain exceptions. But if I click on here and I do whatever the standard says, I'd have to come back to here and then follow the rest of these, whatever. But this should go, so it does. So this one does this. Here, whatever. So that comes down to here. It's not going to highlight correctly because this is a modern operating system, and this is how the modern operating system works. Since it's modern, this operating system, they call it, by they I mean, I don't know, you know, like people that do computers and stuff that say computers like super advanced and we buy their products, they sell to us, and they tell us it's a modern operating system. When I highlight here, I can't just highlight where I'm trying to highlight because it's a modern operating system, so it's gonna highlight other things too because it's modern operating system. So pretending that it highlighted only what I wanted it to highlight, which wasn't this whole thing. I just lost whatever I thought. But this keeps getting deeper and deeper. But overall, what I think I can do is make shortcuts, because if I were to physically write the engine out following all the chain of operations that they say, it's going to get really slow. So I can actually tweak the engine, pull in the parts that I need, and then shortcut things so it's not a function call for every single thing. I can inline it and whatever it's called, I don't know, just like logically map out whatever outcomes to like shorten the chain of operations that are completed, as long as it meets the condition, whatever. It shouldn't have to follow calling every single sub condition if it can be optimized, and I will be doing that because there's no way anybody actually follows every single clause, because it'd be very, very slow. And if they do, that would explain why it's so very, very slow. Plus with all these like conditions here, there's no reason to whatever. And I want to break it down each one to make sure I don't have memory leaks and stuff. So like as I go through, I don't know, I have to like hand tune all this stuff, whatever. And I need browser extensions so I can make it so that like if this is whatever, it's not going to highlight because it's the modern operating system. I want it to highlight just as false. I'll just highlight here. Now it's all not. That works. I can add extensions to the JavaScript engine so people can attach C code to like if there's some new preset standard added, they could add a part of it. Like if it was this, for example, they could add it themselves. So I don't have to, or if they have something exclusive to their browser vendor JavaScript engine, they can add it on whatever. Okay, so I think that like literally, I don't know, that's the weird, covers every single thing. So I get back to here, I explained the chapter. And then can bring all the other files, and then finalizing the epilogue. That's when I would add browser support, not browser support. It's not a browser. Oh, I'd add support for JavaScript vendors, which are probably people that have a browser, but not always. To add like different parts of the standard if things are added, or if they have something exclusive to their vendor. Like I said, that's what I would do in the epilogue when I change the title of the videos at the bottom to epilogue. Okay, so after all that, after the epilogue, and this whatever, like I said here, then I don't know, it's done and ready for release. So now that I like explained all that, I'm gonna have to come up with like a shorter way to explain all that that covers everything, so I could like watch this back later, I guess, and explain it now and then, because nobody's gonna watch those videos. I wouldn't watch these videos, and if you're watching this, stop watching it, go live your life and do your own thing, because I'm just documenting this only for the purpose of the chapter part, which I said earlier why. So when I release it, everything is there, every single thing, all the choices I made, the proof that it runs, everything, whatever, all recorded. I'm going to timestamp it, I'm going to show the code when it's like showable, but like when the code itself I won't show. But the fact that it meets some part of the standard, or choices I make depending on the subclause, or things like the word leak. I think it says leak here. I'll be able to like prove when going through the standard that based on my logic when I'm explaining whatever, I can like point out if something's different, like, oh, mine doesn't have this kind of a leak or whatever's in the subclause. I can like explain everything, all videotaped, live stream. I get to the epilogue. That's the whole point of any of this. Alright, now I actually summarized everything. So like, I'm gonna do I'm gonna explain it again from the top. I'm gonna do this. I'm gonna parse the chat bytecode, that's what I'm doing right now. And then, next 5 days, try to do this stuff. Like, I don't know if I can explain it, because I already explained so much. That's like, the whole overall the behind the thoughts of the thoughts of thoughts, trying to explain everything. I think that was like 30 minutes. So I'm doing this now. Now I'm gonna get to this today. And then tomorrow, if there's any of this left, I'm gonna do this. And then after 4 days, 5 days, however many day countdown, hopefully I'll get to this point. After that point, the whole point of doing this, I'll get to this point. And I'll work on this, and then other little things in between. And after it meets the standard, everything runs, I'm gonna do this point down here. Okay, so now that I said point, and I highlight, since I explained all that for 30 minutes, you actually kind of possibly understand what that means. Because when I make the points, I try to explain it, it's not possible like remember all the parts of that point, or even what that point means. But now, everything should have meaning. Alright, I'm like gonna shut up and then do this. I'm gonna I think I'm gonna edit the video or the last 30 minutes. I'll cut out all the parts I don't need. I'll make a little video so I can hit play. I might have to find a better example. I might have to remake it, but I won't do it live. So I can hit play and then show it, and I'll play it every now and then, because I can't explain it all the time. And I need a good example that explains it once, so I can just hit play, whatever. So I'm doing this now. I'm gonna go drink some water. And I have no thoughts left in my head. Everything's been explained out. So I'm gonna do this when I get back. Okay, but I just remembered. This is the 2024 language specs, whatever. Okay, it has the word leak, and they acknowledge that they exist or could exist depending on the implementation. And they provide oh, here's 2 possible solutions. We can't say they work or how to implement them, but here's what you could do. But when I go to an older documentation of the same standard, this is a 2009 ECMA language spec. It's almost the same. Except most importantly, as you can see, the color palette is slightly different visually, but due to compressed video and limited color in the modern browser and subsampling and everything, the color palettes may look exactly the same. Also because it's 2025 and we use more commonly, generally, 99% of people have monitors with 8-bit color, which is 1 byte. We have 64-bit computers and red, green, blue are all limited to 1 byte. 8-bit color. There are 10-bit monitors, 12-bit monitors, and I think 14-bit monitors. They have higher color resolution, which means it's better at what's the word? Recreating what's a stupid word for it? Replicating, which means that 10-bit monitors have better color replication, because you'll never get exact, but it has a greater range of color, so it looks, you get more in-depth colors and stuff. So since it's everything's modern and 8-bit color is acceptable, and it's also acceptable to sell 10-bit monitors that have 8-bit displays, and then say with frame rate control we give you 10-bit color, so they're like lying, it doesn't look like 10-bit. I have a 10-bit, true 10-bit monitor, and a 10-bit monitor that has an 8-bit panel with frame rate control. You can tell which one is 10-bit color and which one's not. It's like really, really obvious. But they can sell products that they say are 10-bit. Especially Apple. All the new displays, they say, oh, it's 10-bit color, billions of color. It's complete crap. They used to have 10-bit color. Okay, so as you can see, the color palette is different. I like graphic design and stuff. I find it really important. That's totally unrelated. Again, the color palette's different. The new one does look better. This one's a little bit dark. This one looks better. So, the main point, this is the 2009 standard, the same standard. I'm going to do Command F to search the standard. And I type in the word leak. And I click next to find where the word leak shows up. There is no word leak. So at some point between 2009, here's the 2009 standard, and the 2024 standard, the word leak showed up in the document, because when I do search for leak in the 2024, it has the word leak in it. So, as I'm going through the standard, one thing I want to figure out is at what point was the memory leak acceptable, or did the memory leak relating to this? I'm sure there's other issues that haven't been, whatever, I guess just this, whatever, with the references and reference count. Was it originally like existent but not talked about, and then in 2024 they're like, we gotta put the word leak in there, we gotta address this and say it's okay because there's lots of issues, we just have to say it's okay because we don't want people complaining about, oh, it leaks memory. So was that known originally, or since 2009 has the engine itself changed the logic, and was a leak created to the point where, oh, it's a leak? So like either it's always been there in the logic, or it was created, or they've known about it, they didn't say anything back then, or they say something now. So I kind of want to like go through both these as I'm going through this, whatever. I'll be checking this one too. This their standard. because I'm literally going from page 1, this is from yesterday, to page 804 down here of the standard. I'm going to meet the whole thing, top to bottom, 100%. And the proof is you can click on the video, you can watch 2 months worth of live streams, and I'm going to support this whole thing, even though it has these huge flaws in it. My JavaScript engine doesn't have leaks and won'ts, so I'm not going to meet those parts of standard. That's not acceptable. I'm setting a new standard. Yeah, whatever. So I'm going to try to like compare between the past standard and this standard. Since I'm going through up to 104 page, I'll be able to know like, oh, this is what happened, because I'm literally going through the whole thing top to bottom, and I'll actually literally know. And I'll know without having to, like, it's not going to be like a side mission or whatever, like a distraction. I'll just intuitively, I can't even talk, I need some water. I'll intuitively figure that out. I need some water, I'm so thirsty. Because I'm literally going through, thinking about this whole thing, absorbing it, and I'll know whatever. So then, by page 804 or whatever, I'll know to myself, was memory leak always there? Did they add it? Or whatever I just said earlier. Okay, I just wanted to point that out, whatever I was just pointing out. So, at least this new color palette, it looks better with these mute colors. So visually, it does look better. It depends on the modern operating system and partial color, streaming service, compression. These colors may look exactly the same because they're close. In your display, if you have a AP display that's really old, they've had 10-bit displays for 10-20 years. But the general public, we're all supposed to be happy with shitty tech and being sold shit because we just consume shit and they give us shit. That's it. That's how the world goes around. I don't know. So you may not be able to see the color difference. So I don't know if leaks were an old standard or only the new standard, but at least, even if memory leaks existed, at least they fixed the color. This color palette is less harsh on the eyes. This one's a little bit too bold. This is easier to look at with muted colors. So that's a positive out of all this. I just want to point that out because I'm usually really negative and truthful. I'm like, well, whatever. So that was the last thing that I don't know, it's like, oh, I forgot. So I remembered and I said it. I'm gonna take a break. I'll be back before I forget something else. And when I get back, I'm going to do this. And then this. And then that's for today. And then tomorrow, hopefully this for the next 5 days. Unless there is some of this left. So when I get back, I'm doing this, and I'll be okay. I need water. I'm so dry from talking.
The 7th of March 2021 Ordinary Has instance. C. O. The abstract operation ordinary has instance takes argument C, an ECMAScript language value, and O, an ECMAScript language value, and returns either a normal completion containing a Boolean or a throw completion. It implements the default algorithm for determining if O inherits from the instance object inheritance path provided by C. It performs the following steps when called. If is callable, C is false. return false. If C has an internal slot, then a let BC be return. Instantia of operator O, BC. If O is not an object, return false. Let P be. Get C, prototype. If P is not an object, throw a type error exception. Repeat ABC, 3.22. Set O to O. If O is null, return false. If same value, P, O, is true, return true. Species constructor O, default constructor. The abstract operation species constructor takes argument so, an object, and default constructor, a constructor, and returns either a normal completion containing a constructor or a throw completion. It is used to retrieve the constructor that should be used to create new objects that are derived from a default constructor as the constructor to use if a constructor at species property cannot be found starting from O. It performs the following steps when called. Let C be. Get O, constructor. If C is undefined, return default constructor. If C is not an object, throw a type error exception. Let S be. Get C, at species. If S is either undefined or null, return default constructor. If this constructor, S, is true, return S. Throw a type error exception. 3.23 enumerable own properties. O, kind. The abstract operation enumerable own properties takes arguments so, an object, and kind, key, value, or key plus value, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It performs the following steps when called. Let own keys be. O. Let results be a new empty list. For each element key of own keys, do if key is a string, then 2. ECMA International 2024. I let desk be. O. Key 2. If desk is not undefined and desk is true, then if kind is key, then A append key to results. Else a let value be. Get O, key B. If kind is value, then I append value to results. C. Else I assert kind is key plus value. 2. Let entry be. Create array from list key value. 3. Append entry to results. 3.24 Get function realm obj. The abstract operation get function realm takes argument obj, a function object, and returns either a normal completion containing a realm record or a throw completion. It performs the following steps when called. If obj has an internal slot, then a return obj. If obj is a bound function exotic object, then a let bound target function be obj. T function be return. Get function realm bound target function. If obj is a proxy exotic object, then a perform. Validate non-revoke proxy obj. B. Let proxy target be obj. C. Return. Get function realm proxy target. Return the current realm record. 3.25 Copy data properties. Target, source, excluded items. The abstract operation copy data properties takes arguments target, an object, source, an ECMAScript language value, and excluded items, a list of property keys, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If source is either undefined or null, return unused. Let from B. To object, source, let keys be from. For each element next key of keys, do a let excluded be false. B. For each element of excluded items, do I have same value, E, next key, is true, then 1. Set excluded to true. C. If excluded is false, then I let desk be from, next key 2. If desk is not undefined and desk is true, then let proper value be. Get from, next key perform. Create data property or throw, target, next key, proper value. Return unused. Return results. Note step 4 will only be reached if obj is a non-standard function exotic object that does not have an internal slot. Note the target passed in here is always a newly created object which is not directly accessible in case of an error being thrown. ECMA International 2024-83. The 7th of March 2026 Private element find. O. P. The abstract operation private element find takes argument so, an object, and P, a private name, and returns a private element or empty. It performs the following steps when called. If O contains a private element pay such that pay return empty, 3.27 private field add O P value. The abstract operation private field add takes argument so an object P, a private name, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If the host is a web browser, then a perform. Host ensure can add private element. O. Let entry be private element find. O. P. If entry is not empty, throw a type error exception. Append private element. Field. Value. To O. Return unused. 3.28 private method or accessor add. O. Method. The abstract operation private method or accessor add takes argument so, an object, and method, a private element, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Method is either method or accessor. If the host is a web browser, then a perform. Host ensure can add private element. O. Let entry be private element find. O. Method. If entry is not empty, throw a type error exception. Append method to O. Return unused. 3.29 host ensure can add private element. O. The host-defined abstract operation host ensure can add private element takes argument O, an object, and returns either a normal completion containing unused or a throw completion. It allows host environments to prevent the addition of private elements to particular host-defined exotic objects. An implementation of host ensure can add private element must conform to the following requirements. If O is not a host-defined exotic object, this abstract operation must return normal completion, unused, and perform no other steps. Any two calls of this abstract operation with the same argument must return the same kind of completion record. The default implementation of host ensure can add private element is to return normal completion, unused. This abstract operation is only invoked by ECMAScript hosts that are web browsers. Note the values for private methods and accessors are shared across instances. This operation does not create a new copy of the method or accessor. 4. Copyright sign, ECMA International 2024, the 7th of March 1930 private get. O. P. The abstract operation private get takes argument so, an object, and P, a private name, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let entry be private element find. O. P. If entry is empty, throw a type error exception. If entry is either field or method, then a return entry. Assert. Entry is accessor. If entry, let getter be entry. Return. Call. Getter. O, 3.31 private set. O. P. Value. The abstract operation private set takes argument so, an object, P, a private name, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let entry be private element find. O. P. If entry is empty, throw a type error exception. If entry is field, then a set entry to value. Else if entry is method, then A throw a type error exception. Else A assert. Entry is accessor. B if entry. C let setter be entry. D perform. Call. Setter. O. Value. Return unused. 3.32 define field. Receiver. Field record. The abstract operation define field takes arguments receiver, an object, and field record, a class field definition record, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let field name be field record. Let initializer be field record. If initializer is not empty, then a let init value be. Call. Initializer. Receiver 4. Else a let init value be undefined. If field name is a private name, then a perform. Private field add. Receiver. Field name. Init value. Else A assert. Is property key. Field name. Is true. B perform. Create data property or throw. Receiver. Field name. init value, return unused. ECMA International 2024-85. The 7th of March 1933. Initialize instance elements. O. Constructor. The abstract operation initialize instance elements takes arguments O, an object, and constructor, an ECMAScript function object, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let methods be the value of constructor. For each private element method of methods, do a perform. Private method or accessor add. O. Method. Let fields be the value of constructor. For each element field record of fields, do a perform. Define field. O. Field record 5. Return unused, 3.34 add value to keyed group. Groups. Key. Value. The abstract operation add value to keyed group takes arguments groups, a list of records with fields, a list of ECMAScript language values, key, an ECMAScript language value, and value, an ECMAScript language value, and returns unused. It performs the following steps when called. For each record, G of groups, do A of same value, G, I assert, exactly one element of groups meets this criterion. 2. Append value to G. 3. Return unused. Let group be the record. Value. Append group to groups. Return unused, 3.35 group by. Items. Callback and key coercion. The abstract operation group by takes arguments items, an ECMAScript language value, callback and an ECMAScript language value, and key coercion, property or 0. And returns either a normal completion containing a list of records with fields, a list of ECMAScript language values, or a throw completion. It performs the following steps when called. Perform. Require object coercible. Items. If is callable. Callback and is false. Throw type error exception. Let groups be a new empty list. Let iterator record be. Get iterator. Items. Sync. Let 0 repeat. 6. ECMA International 2024. A, B, C, D, E, F, G, H. If K253 1, then I let error be throw completion, a newly created type error object. 2. Return. Iterator close. Iterator record. Error. Let next be. Iterator step value. Iterator record. If next is done, then I return groups. Let value be next. Let key be completion. Call. Callback and undefined value k. If abrupt close iterator key iterator record. If key coercion is property, then I set key to completion to property key 2. If abrupt close iterator key iterator record. Else I 2 assert key coercion is 0. If key is -0, set key to +0. I perfo rm add value to keyed group. Groups. Key. Value. J set k to k plus 1.4 operations on iterator objects. See common iteration interfaces. 27.1, 4.1 iterator records. An iterator record is a record value used to encapsulate an iterator or async iterator along with the next method. Iterator records have the fields listed in Table 15. Table 15. Iterator record fields. Field name. Value. Meaning. Iterator. An object that conforms to the iterator or async iterator interface. Next method. An ECMAScript language value. The next method of the object. Done. A boolean. Whether the iterator has been closed. 7. 4. To get iterator from method. OBJ. Method. The abstract operation get iterator from method takes arguments OBJ, an ECMAScript language value, and method, a function object, and returns either a normal completion containing an iterator record or a throw completion. It performs the following steps when called. Let iterator be. Call. Method. OBJ. If iterator is not an object, throw a type error exception. Let next method be. Get. Iterator. Next. Let iterator record be the iterator record. Iterator. Next method. False. Return iterator record, 4.3 get iterator. OBJ. Kind. The abstract operation get iterator takes arguments OBJ, an ECMAScript language value, and kind, sync or async, and returns either a normal completion containing an iterator record or a throw completion. It performs the following steps when called. If kind is async, then a let method be get method obj add at async iterator b. If method is undefined, then I let sync method be get method obj add at iterator 2. If sync method is undefined, throw a type error exception 3. Let sync iterator record be get iterator from method obj sync method 5. Return create a sync from sync iterator record. Else a let method be get method obj add at iterator. If method is undefined, throw a type error exception. Return get iterator from method obj method. ECMA International 2024 87 7 4. For iterator next iterator record value. The abstract operation iterator next takes argument iterator record, an iterator record, and optional argument value, an ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. If value is not present, then a let result be call iterator record, else a let result be call iterator record value. If result is not an object, throw a type error exception. Return result, 4.5 iterator complete iter result. The abstract operation iterator complete takes argument iter result, an object, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return to boolean get iter result done, 4.6 iterator value iter result. The abstract operation iterator value takes argument iter result, an object, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. 1. Return get iter result value, 4.7 iterator step iterator record. The abstract operation iterator step takes argument iterator record, an iterator record, and returns either a normal completion containing either an object or false, or a throw completion. It requests the next value from iterator record by calling iterator record and returns either false indicating that the iterator has reached its end or the iterator result object if a next value is available. It performs the following steps when called. Let result be iterator next iterator record. Let done be iterator complete result. If done is true, return false. Return result, 4.8 iterator step value iterator record. The abstract operation iterator step value takes argument iterator record, an iterator record, and returns either a normal completion containing either an ECMAScript language value or done, or a throw completion. It requests the next value from iterator record by calling iterator record and returns either done indicating that the iterator has reached its end or the value from the iterator result object if a next value is available. It performs the following steps when called. Let result be completion, iterator next, iterator record. If result is a throw completion, then A set iterator record to true, B return result, set result to result. Let done be completion, iterator complete result. If done is a throw completion, then A set iterator record to true, B return done, set done to done. 8. ECMA International 2024 7. If done is true, then A set iterator record to true, B return done. Let value be completion, get result value. If value is a throw completion, then A set iterator record to true 10. Return value, 4.9 iterator close, iterator record completion. The abstract operation iterator close takes arguments iterator record, an iterator record, and completion, a completion record, and returns a completion record. It is used to notify an iterator that it should perform any actions it would normally perform when it has reached its completed state. It performs the following steps when called. Assert iterator record is an object. Let iterator be iterator record. Let inner result be completion, get method iterator return. If inner result is a normal completion, then a let return be inner result. B if return is undefined, return completion. C set inner result to completion, call return iterator. If completion is a throw completion, return completion. If I in a result is a throw completion, return in a result. If in a result is not an object, throw a type error exception. Return completion, 4.10 if abrupt close iterator, value, iterator record. If abrupt close iterator is a shorthand for a sequence of algorithm steps that use an iterator record. An algorithm step of the form. If abrupt close iterator, value, iterator record means the same thing as assert. Value is a completion record. If value is an abrupt completion, return. Iterator close, iterator record, value, else. Set value to value, 4.11 async iterator close, iterator record, completion. The abstract operation async iterator close takes arguments iterator record, an iterator record, and completion, a completion record, and returns a completion record. It is used to notify an async iterator that it should perform any actions it would normally perform when it has reached its completed state. It performs the following steps when called. Assert. Iterator record is an object. Let iterator be iterator record. Let in a result be completion. Get method. Iterator. Return. If in a result is a normal completion, then a let return be in a result. B if return is undefined. Return completion. C set in a result to completion. Call. Return, iterator. D if in a result is a normal completion, set in a result to completion, await, in a result. If completion is a throw completion, return completion. If in a result is a throw completion, return in a result. If in a result is not an object, throw a type error exception. Return completion. ECMA International 2024-89. The 7th of April 2012. Create iter result object, value, done. The abstract operation create iter result object takes arguments value, an ECMAScript language value, and a boolean, and returns an object that conforms to the iterator result interface. It creates an object that conforms to the iterator result interface. It performs the following steps when called. Let obj be ordinary object create, %object prototype %perform. Create data property or throw, obj, value, perform. Create data property or throw, obj, done, return obj, 4.13 create list iterator record, list. The abstract operation create list iterator record takes argument list, a list of ECMAScript language values, and returns an iterator record. It creates an iterator, 27112. Object record whose next method returns the successive elements of list. It performs the following steps when called. Let closure be a new abstract closure with no parameters that captures list and performs the following steps when called. For each element of list, do I perform. Generate a yield. Create iter result object, E, false. B return normal completion, undefined. Let iterator be create iterator from closure, empty. %iterator prototype return the iterator record. Iter generate a function prototype next false. Note the list iterator object is never directly accessible to ECMAScript code. 4.14 iterator to list. Iterator record. The abstract operation iterator to list takes argument iterator record, an iterator record, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It performs the following steps when called. Let values be a new empty list 2. Repeat. A let next be. Iterator step value. Iterator record. B if next is done, then I return values. C append next to values. Syntax directed operations. In addition to those defined in this section, specialized syntax-directed operations are defined throughout this specification. Point 1 Runtime semantics. Evaluation. The syntax-directed operation evaluation takes no arguments and returns a completion record. Note the definitions for this operation are distributed over the ECMAScript language sections of this specification. Each definition appears after the defining occurrence of the relevant productions. 0. Copyright sign. ECMA International 2024. 8.2 Scope Analysis. 2.1 Static Semantics. Bound names. The syntax-directed operation bound names takes no arguments and returns a list of strings. Note default is used within this specification as a synthetic name for a module's default export when it does not have another name. An entry in the modules is created with that name and holds the corresponding value, and resolving the export name default by calling resolve export, export name, resolve set. For the module will return a resolved binding record whose is default, which will then resolve in the modules to the above-mentioned value. This is done only for ease of specification, so that anonymous default exports can be resolved like any other export. This default string is never accessible to ECMAScript code or to the module linking algorithm. It is defined piecewise over the following productions: binding identifier, identifier, return a list whose sole element is the string value of identifier, binding identifier, yield 1. Return yield, binding identifier, await 1. Return await, lexical declaration, let or const binding list. 1. Return the bound names of binding list. Binding list, lexical binding. Let names 1 be the bound names of binding list. Let names 2 be the bound names of lexical binding. Return the list concatenation of names 1 and names 2. Lexical binding, binding identifier initializer opt1. Return the bound names of binding identifier. Lexical binding, binding pattern initializer. Return the bound names of binding pattern. Variable declaration list, variable declaration list. Variable declaration. Let names 1 be bound names of variable declaration list. Let names 2 be bound names of variable declaration. Return the list concatenation of names 1 and d names 2. Variable declaration, binding identifier initializer opt1. Return the bound names of binding identifier. ECMA International 2024-91. Variable declaration, binding pattern initializer 1. Return the bound names of binding pattern. Object binding pattern, 1. Return a new empty list. Object binding pattern, binding property list, binding rest property. Let names 1 be bound names of binding property list. Let names 2 be bound names of binding rest property. Return the list concatenation of names 1 and names 2. Array binding pattern, ELIGE not, 1. Return a new empty list. Array binding pattern, ELIGE not binding rest element, 1. Return the bound names of binding rest element. Array binding pattern, binding element list, ELIGE not, 1. Return the bound names of binding element list. Array binding pattern, binding element list, ELIGE not binding rest element. Let names 1 be bound names of binding element list. Let names 2 be bound names of binding rest element. Return the list concatenation of names 1 and names 2. Binding property list, binding property list, binding property. Let names 1 be bound names of binding property list. Let names 2 be bound names of binding property. Return the list concatenation of names 1 and names 2. Binding element list, binding element list, binding elision element. Let names 1 be bound names of binding element list. Let names 2 be bound names of binding elision element. Return the list concatenation of names 1 and names 2. Binding elision element, ELIGE not binding element 1. Return bound names of binding element. Binding property, property name, binding element 1. Return the bound names of binding element. Single name binding, binding identifier initializer opt1. Return the bound names of binding identifier. Binding element, binding pattern initializer opt1. Return the bound names of binding pattern. 2. ECMA International 2024. For declaration, let or const for binding 1. Return the bound names of for binding. Function declaration, function binding identifier, formal parameters, function body, 1. Return the bound names of binding identifier. Function declaration, function, formal parameters, function body, 1. Return default, formal parameters, empty, 1. Return a new empty list. Formal parameters, formal parameter list, function rest parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of function rest parameter. Return the list concatenation of names 1 and names 2. Formal parameter list, formal parameter list, formal parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of formal parameter. Return the list concatenation of names 1 and names 2. Arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the array formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return the bound names of formals. Generate a declaration. Function binding identifier. Form. Al parameters. Generate a body. Return the bound names of binding identifier. Generate a declaration. Function. Formal parameters. Generate a body. Return default. Async. Generate a declaration. Async function binding identifier. Formal parameters. Async. Generate a body. Return the bound names of binding identifier. Async. Generate a declaration. Async function. Formal parameters. Async. Generate a body. 1. Return default. Class declaration. Class binding identifier class tail 1. Return the bound names of binding identifier. Class declaration. Class tail 1. Return default. ECMA International 2024-93. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Return the bound names of binding identifier. Async function declaration. Async function. Formal parameters. Async function body. Return default. Capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Member expression arguments. Let head be the async arrowhead that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Return the bound names of head. Import declaration. Import clause from clause. 1. Return the bound names of import clause. Import declaration. Import module specifier. 1. Return a new empty list. Import clause. Imported default binding. Namespace import. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of namespace import. Return the list concatenation of names 1 and names 2. Import clause. Imported default binding. Named imports. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of named imports. Return the list concatenation of names 1 and names 2. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. Let names 1 be the bound names of imports list. Let names 2 be the bound names of import specifier. Return the list concatenation of names 1 and names 2. Import specifier. Module export name as imported binding 1. Return the bound names of imported binding. Export declaration. Export from clause. Export named exports. Return a new empty list. Export declaration. Export variable statement. Return the bound names of variable statement. Export declaration. Export declaration. Return the bound names of declaration 94. ECMA International 2024. Export declaration. Export default hoistable declaration. Let declaration names be the bound names of hoistable declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default class declaration. Let declaration names be the bound names of class declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default assignment expression. 1. return default, 2.2 static semantics, declaration part. The syntax-directed operation declaration part takes no arguments and returns a parse node. It is defined piecewise over the following productions: hoistable declaration, function declaration, return function declaration, hoistable declaration, generator declaration, return generator declaration, hoistable declaration, async function declaration, return async function declaration, hoistable declaration, async generator declaration, return async generator declaration, declaration, class declaration, return class declaration, declaration, lexical declaration, return lexical declaration, 2.3 static semantics, is constant declaration. The syntax-directed operation is constant declaration, takes no arguments and returns a boolean. It is defined piecewise over the following productions: lexical declaration, let or const binding list. Return is constant declaration of let or const. Let or const, let return false. Let or const, const return true. ECMA International 2024-95. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return false, class declaration, class binding identifier, class tail 1. Return false, export declaration, export from clause, export named exports, export default assignment expression, return false, 2.4 static semantics, lexically declared names. The syntax-directed operation lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: block, return a new empty list, statement list item. Let names 1 be lexically declared names of statement list. Let names 2 be lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement, if statement is statement, labeled statement, return lexically declared names of labeled statement. Return a new empty list. Statement list item. Declaration. Return the bound names of declaration. It is not necessary to treat export default assignment expression as a constant declaration. Note, because there is no syntax that permits assignment to the internal bound name used to reference a module's default object. 6. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt default clause case clause assopt. If the first case clause S is present, let names 1 be the lexically declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be lexically declared names of default clause. If the second case clauses is present, let names 3 be the lexically declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clauses case clause. Let names 1 be lexically declared names of case clauses. Let names 2 be lexically declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically declared names of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically declared names of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration. Return bound names of function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return top-level lexically declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top-level lexically declared names of statement list. Concise body. Expression body 1. Return a new empty list. ECMA International 2024-97. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top-level lexically declared names of statement list. Note 2: the lexically declared names of a module includes the names of all of its imported bindings. Module item list. Module item list. Module item. Let names 1 be lexically declared names of module item list. Let names 2 be lexically declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Return the bound names of import declaration. Module item. Export declaration. If export declaration is export variable statement, return a new empty list. Return the bound names of export declaration. Module item. Statement list item. Return lexically declared names of statement list item. 2.5 Static semantics. Lexically scoped declarations. The syntax-directed operation lexically scoped declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be lexically scoped declarations of statement list. Let declarations 2 be lexically scoped declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return lexically scoped declarations of labeled statement. Note 1: at the top level of a script, function declarations are treated like var declarations rather than like lexical declarations. Note 3: at the top level of a module, function declarations are treated like lexical declarations rather than like var declarations. Return a new empty list. Statement list item. Declaration. Return a list whose sole element is declaration part of declaration 98. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let declarations 1 be the lexically scoped declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be lexically scoped declarations of default clause. If the second case clause is present, let declarations 3 be the lexically scoped declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses. Case clause. Let declarations 1 be lexically scoped declarations of case clauses. Let declarations 2 be lexically scoped declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically scoped declarations of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration 1. Return function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. ECMA International 2024-99. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let declarations 1 be lexically scoped declarations of module item list. Let declarations 2 be lexically scoped declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Export declaration. Export from clause fr. On clause. Export named exports. Export variable statement. Return a new empty list. Export declaration. Export declaration. Return a list whose sole element is declaration part of declaration. Export declaration. Export default hoistable declaration. Return a list whose sole element is declaration part of hoistable declaration. Export declaration. Export default class declaration. Return a list whose sole element is class declaration. Export declaration. Export default assignment expression. Return a list whose sole element is this export declaration. 00. ECMA International 2024. 8. 2. 6. Static semantics. var declared names. The syntax directed operation var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, return a new empty list. Block, return a new empty list. Statement list. Statement list item. Let names 1 be var declared names of statement list. Let names 2 be var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration 1. Return a new empty list.
Variable statement, variable deklaration list. 1. Return both names of variable deklaration list.
If statement. If. Expression statement else statement. Let names 1 be var declared names of the first statement. Let names 2 be var declared names of the second statement. Return the list concatenation of names 1 and names 2. If statement. If. Expression statement 1. Return the var declared names of statement. Do while statement. Do statement while. Expression. 1. Return the var declared names of statement while statement. While. Expression statement 1. Return the var declared names of statement for statement. 4. Expression not. Expression not. Expression not statement 1. Return the var declared names of statement for statement. 4. var variable declaration list. Expression not. Expression not statement. Let names 1 be bound names of variable declaration list. Let names 2 be var declared names of statement. Return the list concatenation of names 1 and names 2. ECMA International 2024 101. For statement. 4. Lexical declaration expression not. Expression not statement 1. Return the var declared names of statement for in of statement. 4. Left-hand side expression in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement. Return the var declared names of statement for in of statement. 4. var for binding in expression statement. 4. var for binding of assignment expression statement for our it. var for binding of assignment expression statement. Let names 1 be the bound names of for binding. Let names 2 be the var declared names of statement. Return the list concatenation of names 1 and names 2. Note this section is extended by an XB 3.5 with statement with expression statement 1. Return the var declared names of statement, switch statement, switch, expression, case block 1. Return the var declared names of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let names 1 be the var declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be var declared names of default clause. If the second case clauses is present, let names 3 be the var declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clauses case clause. Let names 1 be var declared names of case clauses. Let names 2 be var declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. 1, 2. If the statement list is present, return the var declared names of statement list. Return a new empty list. 02. ECMA International 2024. Default clause. Default. Statement list opt. If the statement list is present, return the var declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var declared names of labeled item. Labeled item. Function declaration. Return a new empty list. Try statement. Try block catch. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Return the list concatenation of names 1 and names 2. Try statement. Try block finally. Let names 1 be var declared names of block. Let names 2 be var declared names of finally. Return the list concatenation of names 1 and names 2. Try statement. Try block catch finally. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Let names 3 be var declared names of finally. Return the list concatenation of names 1, names 2, and names 3. Catch, catch, catch parameter, block 1. Return the var declared names of block. Function statement list, empty, 1. Return a new empty list. Function statement list. Statement list. Return top-level var declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top-level var declared names of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. ECMA International 2024 103. Script. Empty. Return a new empty list. Script body. Statement list. Return top-level var declared names of statement list. Module item list. Module item. List module item. Let names 1 be var declared names of module item list. Let names 2 be var declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return bound names of export declaration. Return a new empty list. 2.7 static semantics. var scope declarations. The syntax directed operation var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement. Return a new empty list. Block. Return a new empty list. Statement list. Statement list item. Let declarations 1 be var scope declarations of statement list. Let declarations 2 be var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Declaration 1. Return a new empty list. Variable declaration list. Variable declaration 1. Return variable declaration. Variable declaration list. Variable declaration list. Variable declaration. 2. Let declarations 1 be var scope declarations of variable declaration list. Return the list concatenation of declarations 1 and variable declaration 04 ECMA International 2024. If statement, if expression statement else statement. Let declarations 1 be var scope declarations of the first statement. Let declarations 2 be var scope declarations of the second statement. Return the list concatenation of declarations 1 and declarations 2. If statement, if expression statement. Return the var scope declarations of statement. Do while statement. Do statement while. Expression 1. Return the var scope declarations of statement. While statement. While. Expression statement 1. Return the var scope declarations of statement. For statement 4. Expression not. Expression not. Expression not. Statement 1. Return the var scope declarations of statement. For statement 4. Var variable declaration list. Expression not. Expression not. Statement. Let declarations 1 be var scope declarations of variable declaration list. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. For statement 4. Lexical declaration expression not. Expression not. Statement 1. Return the var scope declarations of statement. For in of statement 4. Left-hand side expression in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. For declaration of assignment expression statement. Return the var scope declarations of statement. For in of statement 4. Var for binding in expression statement 4. Var for binding of assignment expression statement. For await. Var for binding of assignment expression statement. Let declarations 1 be for binding. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB 3.5. With statement. With expression statement. Return the var scope declarations of statement. Copyright sign. ECMA International 2024 105. Switch statement. Switch. Expression. Case block 1. Return the var scope declarations of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let declarations 1 be the var scope declarations of the first case clauses. Else. Let declarations 1 be a new empty list. Let declarations 2 be var scope declarations of default clause. If the second case clauses is present, let declarations 3 be the var scope declarations of the second case clauses. Else. Let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses case clause. Let declarations 1 be var scope declarations of case clauses. Let declarations 2 be var scope declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var scope declarations of labeled item. Labeled item. Function declaration 1. Return a new empty list. Try statement. Try block catch. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of finally. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Let declarations 3 be var scope declarations of finally. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch. Catch. catch parameter, block. Return the var scope declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list, statement list. Return the top level var scope declarations of state. Ment list, class static block statement list, empty, 1. Return a new empty list. Class static block statement list, statement list. Return the top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. Async concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module, empty. Return a new empty list. Module item list, module item list, module item. Let declarations 1 be var scope declarations of module item list. Let declarations 2 be var scope declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return var scope declarations of variable statement. Return a new empty list. ECMA International 2024 107 8 2 8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list, statement list item. Let names 1 be top level lexically declared names of statement list. Let names 2 be top level lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list, statement list item. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top level var declared names of statement list. Let names 2 be top level var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a return the bound names of hoistable declaration. Return a new empty list. 108. ECMA International 2024. Note at the top level of a function or script, function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script, in a function declarations are treated like var declarations. Labeled statement, label identifier, labeled item. Return the top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 Static semantics. Top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be top level var scope declarations of statement list. Let declarations 2 be top level var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement, label identifier, labeled item. Return the top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. Copyright sign. ECMA International 2024 109. 8.3 labels, 3.1 Static semantics. Contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item. Declaration, return false. Statement list. Statement list item. Let has duplicates be contains duplicate labels of statement list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of statement list item with argument label set. If statement, if expression statement, else statement. Let has duplicate be contains duplicate labels of the first statement with argument empty label set. If has duplicate is true, return true. Return contains duplicate labels of the second statement with argument label set. If statement, if expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement, for. Expression not statement, for. Var variable declaration list. Expression not statement for. Lexical declaration expression not statement. Return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement. 4. Left-hand side expression in expression statement. 4. Var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement for await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains duplicate labels of statement with argument label set. Note this section is extended by an XB. 3.5 with statement. With expression statement. Return contains duplicate labels of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains duplicate labels of case block with argument label set. Case block. 1. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set is true. Return true. If contains duplicate labels of default clause with argument label set is true. Return true. If the second case clauses is not present, return false. Return contains duplicate labels of the second case clauses with argument label set. Case clauses. Case clauses case clause. Let has duplicates be contains duplicate labels of case clauses with argument label set. If his duplicates is true, return true. Return contains duplicate labels of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. If label set contains label, return true. Let new label set be the list. Concatenation of label set and label. Return contains duplicate labels of labeled item with argument new label set. Copyright sign. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has duplicates be contains duplicate labels of block with argument label set. If his duplicates is true, return true. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. Let has duplicates be contains duplicate labels of block with argument label set. If his duplicates is true, return true. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. If contains duplicate labels of block with argument label set is true, return true. If contains duplicate labels of catch with argument label set is true, return true. Return contains duplicate labels of finally with argument label set. Catch. Catch. Catch parameter. Block. Return contains duplicate labels of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list module item. Let has duplicates be contains duplicate labels of module item list with argument label set. If his duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If statement. If. Expression statement else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If statement. If. Expression statement. Return contains undefined break target of statement with argument label set. Do while statement. do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. For. Expression not. Expression not. Expression not statement. For. V. A variable declaration list. Expression not. Expression not statement. For. Lexical declaration. Expression not. Expression not statement. Return contains undefined break target of statement with argument label set. For in of statement. For. Left-hand side expression in expression statement. For. var for binding in expression statement. For declaration in expression statement. For. Left-hand side expression of assignment expression statement. For. var for binding of assignment expression statement. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5 Break statement. Break. 1. Return false. Copyright sign. ECMA International 2024 113. Break statement. Break label identifier. If label set does not contain the string value of label identifier, return true. Return false. With statement. With expression statement. Return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains undefined break target of the first case clauses with argument label set is true, return true. If contains undefined break target of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains undefined break target of the second case clauses with argument label set. Case clauses. Case clauses case clause. Let has undefined labels be contains undefined break target of case clauses with argument label set. If has undefined labels is true, return true. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. If contains undefined break target of block with argument label set is true, return true. If contains undefined break target of catch with argument label set is true, return true. Return contains undefined break target of finally with argument label set. Catch. Catch. Catch parameter. Block. Return contains undefined break target of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list module item. Let has undefined labels be contains undefined break target of module item list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of module item with argument label set. Module item. import declaration, export declaration, return false, comma 3.3 static semantics, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E. The syntax directed operation, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block statement with arguments iteration set and ECMA International 2024 115, breakable statement, iteration statement. Let new iteration set be the list concatenation of iteration set and label set. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of iteration statement with arguments new iteration set and statement list. Statement list item. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration set and if has undefined labels is true, return true. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list item with arguments iteration set and if statement, if expression statement, else statement. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first statement with arguments iteration set and if has undefined labels is true, return true. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second statement with arguments iteration set and if statement, if expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and do while statement, do statement while, expression, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and while statement, while, expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and for statement 4, expression not statement 4, var variable declaration list, expression not statement 4, lexical declaration expression not statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and for in of statement 4, left hand side expression in expression statement 4, var for binding in expression statement 4, for declaration in expression statement 4, left hand side expression of assignment expression statement 4, var for binding of assignment expression statement 4, for declaration of assignment expression statement for await, left hand side expression of assignment expression statement for await, var for binding of assignment expression statement for await, for declaration of assignment expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and note this section is extended by an XB 3.5 continue statement, continue 1, return false 116 ECMA International 2024 continue statement, continue label identifier if iteration set does not contain the string value of label identifier, return true, return false with statement, with expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and switch statement, switch, expression, case block, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of case block with arguments iteration set and case block return false. Case block case clause assopt default clause case clause assopt. If the first case clauses is present, then if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the first case clauses with arguments iteration set and is true, return true. If capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of default clause with arguments iteration set and is true, return true. If the second case clauses is not present, return false. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the second case clauses with arguments iteration set and case clauses case clause. Let have undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case clauses with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case clause with arguments iteration set and case clause case expression statement list opt. If the statement list is present, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and return false. Default clause default statement list opt. If the statement list is present, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and return false. Labeled statement label identifier labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of labeled item with arguments iteration set and new label set. Labeled item function declaration 1. return false. Try statement, try block catch. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second. If has undefined labels is true, return true. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of catch with arguments iteration second. ECMA International 2024 117. Try statement, try block finally. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second. If has undefined labels is true, return true. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, finally with arguments iteration second. Try statement, try block catch finally. If capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second is true, return true. If capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of catch with arguments iteration second is true, return true. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, finally with arguments iteration second. Catch, catch, catch parameter, block. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block with arguments iteration second. Function statement list empty 1. Return false. Class static block statement list empty 1. Return false. Module item list module item. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E capital T A R G E. A module item list with arguments iteration set and if has undefined labels is true. Return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. A module item with arguments iteration set and module item. Import declaration, export declaration, return false. Point 4 function name inference, comma 4.1 static semantics. Has name. The syntax directed operation has name takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. If this function definition of expa is false, return false. Return his name of expa. Function expression. Function. Formal parameters. Function body. Generator expression. Function. Formal parameters. Generator body. Async generator expression. Async function. Formal parameters. Async generator body. Async function expression. Async function. Formal parameters. Async function body. 18. ECMA International 2024. Arrow function. Arrow parameters equals. Concise body. Async arrow function. Async arrow binding identifier equals. Async concise body. Capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R equals. Async concise body. Class expression. Class tail. Return false. Function expression. Function binding identifier. Formal parameters. Function body. Generator expression. Function binding identifier. Formal parameters. Generator body as int generator expression. Async function binding identifier. Formal parameters. Async generator body. Async function expression. Async function binding identifier. Formal parameters. Async function body. Class expression. Class binding identifier. Class tail. Return true. Comma 4.2 static semantics is function definition. The syntax directed operation is function definition takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return is function definition of expa primary expression. This identifier reference literal, array literal, object literal, regular expression literal, template literal, member expression, expression, member expression. Identifier name member expression template literal super property, meta property, new member expression arguments member expression. Private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, ECMA International 2024 119, update expression, left-hand side expression left-hand side expression, unary expression, delete unary expression, void unary expression, type of unary expression unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative operator, exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instance of shift expression, relational expression in shift expression. Private identifier in shift expression, equality expression equals relational 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 expression, bitwise and expression and equality expression, bitwise or expression, bitwise and expression, bitwise or expression, logical and expression, and bitwise or expression, logical and expression, coalesce expression head, bitwise or expression, conditional expression, short circuit expression, assignment expression, 20, ECMA International 2024, assignment expression, yield expression, left-hand side expressio, N equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, assignment expression, return false, assignment expression, arrow function, async arrow function expression, function binding identifier opt, formal parameters, function body, generator expression, function binding identifier opt, formal parameters, generator body, async generator expression, async function binding identifier opt, formal parameters, async generator body, async function expression, async function binding identifier opt, formal parameters, async function body, class expression, class binding identifier opt, class tail1. Return true, 4.3 static semantics is anonymous function definition, expa. The abstract operation is anonymous function definition takes argument expa, an assignment expression parse node, an initializer parse node, or an expression parse node, and returns a boolean. It determines if its argument is a function definition that does not bind a name. It performs the following steps when called. If its function definition of expa is false, return false. Let hasName be hasName of expa. If hasName is true, return false. Return true, 4.4 static semantics is identifier ref. The syntax-directed operation is identifier ref takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, identifier reference, return true, ECMA International 2024 121. Primary expression, this, literal, array literal, object literal, function expression, class expression, generator expression, async function expression, async generator expression, regular expression literal, template literal, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E S I Z E D capital E X P R E S S I O N capital A N member expression member expression identifier name member expression template literal super property meter property new member expression arguments member expression private identifier new expression new expression left hand side expression call expression optional expression return false comma 4.5 runtime semantics named evaluation the syntax directed operation named evaluation takes argument name a property key or a private name and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N return named evaluation of expa with argument name parenthesized expression assert is anonymous function definition expression is true return named evaluation of expression with argument name function expression function formal parameters funct iron body return capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P a function expression with argument name generator expression function formal parameters generator body return capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital E X of generator expression with argument name async generator expression async function formal parameters async generator body return capital I N S T A N T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T of async generator expression with argument name 22 copyright sign ECMA International 2024 async function expression async function formal parameters async function body 1 return capital I N S T A N T I A T E capital A S Y N C capital F U N C T I O N capital E X P R E S of async function expression with argument name arrow function arrow parameters equals concise body return capital I N S T A N T I A T E capital A capital F U N C T I O N, capital E X P R E S, of arrow function with argument name, async arrow function, async arrow binding identifier equals, async concise body, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, equals, async concise body, return, capital I N S T A N T I A T E, capital A S Y N C, capital A R R O W, capital F U N C T I O N, capital E, of async arrow function with argument name. Class expression, class tail, let value be. Class definition, evaluation of class tail with arguments undefined and name. Set value to the source text match by class expression. Return value. 0.5 contains, 5.1 static semantics. Contains. The syntax directed operation contains takes argument symbol, a grammar symbol, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains for each child node. Child of this parse node. Do if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration, function binding identifier, formal parameters. Function body, function, formal parameters, function body, function expression, function binding identifier opt, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier opt, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier opt, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, ECMA International 2024 123, async function expression, async function binding identifier opt, formal parameters, async function body, return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. CL, as tail, class heritage art, class body. If symbol is class body, return true. If symbol is class heritage, then, if class heritage is present, return true, otherwise return false. 3. If class heritage is present, then, if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block, static, class static block body, 1. Return false. Arrow function, arrow parameters equals, concise body. If symbol is not one of new target, super property, super call, super, or this, return false. If arrow parameters contain symbol is true, return true. Return concise body contains symbol, arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return formals contains symbol async arrow function async arrow binding identifier equals async concise body if symbol is not one of new target super property super call super or this. Return false. Return async concise body contains symbol async arrow function capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body if symbol is not one of new target super property super call super or this. Return false. Let head be the async arrow head that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. If head contains symbol is true, return true. Return async concise body contains symbol 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true, return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super, return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true, return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true, return true. Return false. 5.2 static semantics. Computed property contains. The syntax directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions. Class element name, private identifier, property name, literal property name, return false, property name, C. Computed property name. Return the result of computed property name contains symbol. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Return the result of computed property contains of class element name with argument symbol. Generator method. Class element name. Unique formal parameters. Generator body. Return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return the result of computed property contains of class element name with argument symbol. Class element list. Class element list. Class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. Class element. Class static block 1. Return false. Class element 1. Return false. Async method. Async class element name. Unique formal parameters. Async function body. 1. Return the result of computed property contains of class element name with argument symbol, field definition, class element name initializer opt. Return the result of computed property contains of class element name with argument symbol. Point 6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax-directed operation instantiate function object takes arguments env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J. A function declaration with arguments env and private env. Generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, of generator declaration with arguments env and private env. Async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, of async generator declaration with arguments env and private env. 26. ECMA International 2024. Async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return instantiate async function object of async function declaration with arguments env and private env8. 6. To runtime semantics, binding initialization. The syntax-directed operation binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding identifier, let name be string value of identifier, return, initialize bound name, value, environment, binding identifier, yield, return, initialize bound name, yield, value, environment, binding identifier, await, return, initialize bound name, await, value, environment, binding pattern, object binding pattern, perform, require object coercible, value, return, binding initialization of object binding pattern with arguments value and environment, binding pattern, array binding pattern, let iterator record be, get iterator, value, sync, let result be completion, iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return, iterator close, iterator record, result, return result, object binding pattern, 1. Return unused, object binding pattern, binding property list, perform, property binding initialization of binding property list with arguments value and environment, return unused. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern. Binding rest property. Let excluded names be a new empty list. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding rest property. Let excluded names be. Property binding initialization of binding property list with arguments value and environment. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. 6. 2. 1. Initialize bound name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMAScript language value, and environment an environment record or undefined, and returns either a normal completion containing a new store and abrupt completion. It performs the following steps when called. If environment is not undefined, then a perform environment initialize binding, name, value, be return unused, else a let LHS be. Resolve binding, name be return. Put value, LHS, value, 6.3 runtime semantics. Iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment an environment record or undefined, and return ns either a normal completion containing a new store and abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. A elision with argument iterator record. Array binding pattern. Elision not binding rest element. If the elision is present, then a perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. A elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. A elision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Elision not binding rest element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. If elision is present, then a perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Iterator binding initialization of binding elision element with arguments iterator record and environment. Binding elision element. Elision binding element. Perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of elision with argument iterator record. Return. Iterator binding initialization of binding element with arguments iterator record and environment. Single name binding. Binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. Environment. Let v be undefined. If iterator record is false, then let next be. Iterator step value. Iterator record. B if next is not done, then I set v to next. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v to named evaluation of initializer with argument binding id. B else I let default value be. Evaluation of initializer 2. Set v to get value, default value. If environment is undefined, return. Put value, LHS, v. Return. Initialize reference binding, LHS, v. Binding element. Binding, G pattern initializer opt. Let v be undefined. If iterator record is false, then let next be. Iterator step value. Iterator record. B if next is not done, then I set v to next. If initializer is present and v is undefined, then let default value be. Evaluation of initializer b set v to get value, default value. Return. Binding initialization of binding pattern with arguments v and environment. Binding rest element. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Environment. Let a be. Array create. 0. Let 0. Repeat. A let next be done. B if iterator record is false, then I set next to. Iterator step value. Iterator record C if next is done, then ECMA International 2024 129. I if environment is undefined, return. Put value, LHS, A, 2. Return. Initialize reference binding, LHS, A, deperform. Create data property or throw, A, to string, N, next, E set N to N plus 1. Binding rest element. Binding pattern. Let a be. Array create. 0. Let 0. Repeat. A let next be done. B if iterator record is false, then I set next to. Iterator step value. Iterator record C if next is done, then I return. Binding initialization of binding pattern with arguments A and environment. Deperform. Create data property or throw A to string N. Next, E set N to N plus 1. Formal parameters. Empty. 1. Return unused. Formal parameters. Formal parameter list. Function rest parameter. Perform. Iterator binding initialization of formal parameter list with arguments iterator record and environment. Return. Iterator binding initialization of function rest parameter with arguments iterator record and environment. Formal parameter list. Formal parameter list. Formal parameter. Perform. Iterator binding initialization of formal parameter list with arguments iterator record and environment. Return. Iterator binding initialization of formal parameter with arguments iterator record and environment. Arrow parameters. Binding identifier. Let v be undefined. Assert. Iterator record is false. Let next be. Iterator step value. Iterator record. If next is not done, then set v to next. Return. Binding initialization of binding identifier with arguments v and environment. Arrow parameters. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return. Iterator binding initialization of formals with arguments iterator record and environment. Async arrow binding identifier. Binding identifier. Let v be undefined. Assert. Iterator record is false. Let next be. Iterator step value. Iterator record. If next is not done, then assert v to next. Return. Binding initialization of binding identifier with arguments v and environment. 30. ECMA International 2024. 8. 6. 4. Static semantics. Assignment. Object type. The syntax-directed operation assignment target type takes no arguments and returns simple or invalid. It is defined piecewise over the following productions. Identifier reference. Identifier. If this identifier reference is contained in strict mode code and string value of identifier is either eval or arguments, return invalid. Return simple. Identifier reference. Yield. Await. Call expression. Call expression. Expression. Call expression. Identifier name. Call expression. Private identifier member expression. Member expression. Expression. Member expression. Identifier name super property. Member expression. Private identifier. Return symbol. Primary expression. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return assignment target type of expa. Primary expression. This literal array literal object literal function expression class expression generator expression async function expression async generator expression regular expression literal template literal call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R supercall import call expression arguments call expression template literal new expression new expression member expression template literal new member expression arguments ECMA International 2024 131 new target import meta left hand side expression optional expression update expression left hand side expression plus left hand side expression plus unary expression delete unary expression void unary expression type of unary expression plus unary expression await expression exponentiation expression update expression exponentiation expression multiplicative expression multiplicative operator exponentiation expression additive expression plus multiplicative expression additive expression multiplicative expression shift expression additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instance of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression, equality expression equals relational 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 expression, bitwise and expression, bitwise and expression and equality expression, bitwise or expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression, logical and expression, logical and expression and bitwise or expression. ECMA International 2024. Logical or expression, logical or expression, logical and expression, coalesce expression head. Bitwise or expression, conditional expression, short circuit expression, assignment expression, assignment expression, assignment expression, yield expression, arrow function, async arrow function. Left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, expression, assignment expression, return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition. Identifier reference. Return string value of identifier reference. Property definition. Assignment expression. Return empty. Property definition. Property name. Assignment expression. Return prop name of property name. Literal property name. Identifier name, return string value of identifier name. Literal property name, string literal, return the SV of string literal. Literal property name, numeric literal, let NBR be the numeric value of numeric literal, return. To string, NBR, computed property name, assignment expression, 1. Return empty, ECMA International 2024 133. Method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return prop name of class element name, generator method, class element name, unique formal parameters, generator body, return prop name of class element name, async generator method, async class element name, unique formal parameters, async generator body, return prop name of class element name, class element, class static block 1, return empty, class element, 1, return empty, async method, async class element name, unique formal parameters, async function body, 1, return prop name of class element name, field definition, class element name initializer opt1. Return prop name of class element name, private identifier 1. Return empty, executable code and execution contexts 9.1 environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of ECMAScript code. Usually an environment record is associated with some specific syntactic structure of ECMAScript code such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. Every environment record has an field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, If a function declaration contains two nested function declarations, then the environment records of each of the nested functions will have as their outer environment record the environment record of the current evaluation of the surrounding function. Environment records are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 34. Copyright sign. ECMA International 2024. 9. 1. 1. The environment record type hierarchy. Environment records can be thought of as existing in a simple, object-oriented hierarchy where environment record is an abstract class with three concrete subclasses: declarative environment record, object environment record, and global environment record. Function environment records and module environment records are subclasses of declarative environment record. Environment record. Abstract. A declarative environment record is used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMAScript language values. A function environment record corresponds to the invocation of an ECMAScript function object, and contains bindings for the top-level declarations within that function. It may establish anew this binding. It also captures the state necessary to support supermethod invocations. A module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. It is a global environment record. An object environment record is used to define the effect of ECMAScript elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It says null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. The environment record abstract class includes the abstract specification methods defined in Table 16. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Table 16. Abstract methods of environment records. Method purpose has binding n. Determine if an environment record has a binding for the string value n. Return true if it doesn't, false if it does not. Create mutable binding n. D. Create a new but uninitialized mutable binding in an environment record. The string value n is the text of the bound name. If the Boolean argument d is true, the binding may be subsequently deleted. Create a mutable binding n. S. Create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. If s is true, then attempts to set it after it has been initialized will always throw an exception, regardless of the strict mode setting of operations that reference that binding. Initialize binding n. V. Set the value of an already existing but uninitialized binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. Set mutable binding n. V. S. Set the value of an already existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. Copyright sign. ECMA International 2024. 35. Table 16. Abstract methods of environment records. Continued. Method purpose get binding value n. S returns the value of an already existing binding from an environment record. The string value n is the text of the bound name. S is used to identify references originating in strict mode code or that otherwise require strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception. If the binding exists but is uninitialized, a reference error is thrown, regardless of the value of S. Delete binding n. Delete a binding from an environment record. The string value n is the text of the bound name. If a binding for n exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Has this binding? Determine if an environment record establishes this binding. Return true if it doesn't. False if it does not. Has super binding. Determine if an environment record establishes a super method binding. Return true if it doesn't. False if it does not. With base object. If this environment record is associated with a with statement, return the with object. Otherwise, return undefined. 9. 1. 1. 1 declarative environment records. Each declarative environment record is associated with an ECMAScript program scope containing variable, constant, let, class, module, import, and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms. 1. 1. 1. 1 has binding. N. The has binding concrete method of a declarative environment record. The envrec takes argument n, a string, and returns a normal completion containing a boolean. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. If envrec has a binding for n, return true, return false, 1, 1, 1. 2. Create mutable binding. N, D. The create mutable binding concrete method of a declarative environment record. The envrec takes arguments n, a string, and e, a boolean, and returns a normal completion containing unused. It creates a new mutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if d is true. The new binding is marked as being subject to deletion. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create a mutable binding in envrec for n and record that it is uninitialized. If d is true, record that the newly created binding may be deleted by a subsequent delete binding call. Return unused. 36. ECMA International 2024. 9. 1. 1. 1. 3. Create a mutable binding. N. S. The create a mutable binding concrete method of a declarative environment record. The envrec takes arguments n, a string, and s, a boolean, and returns a normal completion containing unused. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. If s is true, record that the newly created binding is a strict binding. Return unused. 1. 1. 1. 4. Initialize binding. N. V. The initialize binding concrete method of a declarative environment record. The envrec takes arguments n, a string, and v, an ECMAScript language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Assert. envrec must have an uninitialized binding for n. Set the bound value for n in envrec to v. Record that the binding for n in envrec has been initialized. Return unused. 1. 1. 1. 5. Set mutable binding. N. V. S. The set mutable binding concrete method of a declarative environment record. The envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. A binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if s is true. It performs the following steps when called. If envrec does not have a binding for n, then if s is true, throw a reference error exception. B. Perform envrec create mutable binding. N. True. C. Perform envrec initialize binding. N. V. D. Return unused. If the binding for n in envrec is a strict binding, set s to true. If the binding for n in envrec has not yet been initialized, then A. Throw a reference error exception. Else if the binding for n in envrec is a mutable binding, then a change its bound value to v, else a assert. This is an attempt to change the value of an immutable binding. B if s is true. Throw a type error exception. Return unused. Note an example of ECMAScript code that results in a missing binding at step 1 is function f eval var x equals delete x 0 ECMA International 2024 137 9 1 1 1 6 get binding value n s. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec, 1 1 1 7 delete binding n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1 1 1 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 9 has super binding. The has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 1 0 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1 1 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign. ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17. Additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 1 1 2 1 has binding n. The has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be. Has property binding object n. If found binding is false, return false. If envrec is false, return true. Let unscopables be. Get binding object Add at unscopables. If unscopables is an object, then a let block be to boolean. Get unscopables, n b if blocked is true, return false, return true, 1, 1, 2. To create mutable binding, n d. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates an environment records associated binding object to property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called. Let binding object be envrec. Perform. Define property or throw binding object n. Property descriptor u defined. True, true. D. Return unused. Field name. Value. Meaning. Binding object. An object. The binding object of this environment record is with environment. A boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3 Create a mutable binding n s. The create a mutable binding concrete method of an object environment record is never used within this specification, 1 1 2 4 Initialize binding n v. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. It performs the following steps when called. Perform envrec set mutable binding n v. False. Return unused, 1 1 2 5 Set mutable binding n v s. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment records associated binding object's property whose name is n to the value v. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let binding object be envrec. Let still exist as b. Has property binding object n. If still exists as false and s is true, throw a reference error exception. Perform. Set binding object n v s. Return unused, 1 1 2 6 Get binding value n s. The get binding value concrete method of an object environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called. Let binding object be envrec. Let value be. Has property binding object n. If a value is false, then if s is false, return undefined. Otherwise throw a reference error exception for return. Get binding object n, 1 1 2 7 Delete binding n. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object n 40 ECMA International 2024 9 1 1 2 8 has this binding. The has this binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 9 has super binding. The has super binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 1, 0 with base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined, 1, 1, 3 function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides a this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18. Additional fields of function environment records. Note: object environment records do not provide a this binding. Note: object environment records do not provide a super binding. Field name, value, meaning this value, an ECMAScript language value. This is the this value used for this invocation of the function. This binding status, lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object, an ECMAScript function object. The function object whose invocation caused this environment record to be created. New target, an object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. tar, ble 19. Additional methods of function environment records. Method, purpose, bind this value. V. Set the end record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if the this binding has not been initialized. Get super base. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms. 1, 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert: envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3. 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 1, 3. 3 has super binding. The has super binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true. 1, 1, 3. 4 get this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert: envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42. ECMA International 2024. 9, 1, 1, 3. 5 get super base. The getSuperbase concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert home is an object. Return home, 1. For global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMAScript script elements that are processed in a common realm. A global environment record provide the bindings for built-in globals, clause 19, properties of the global object, and for all top-level declarations, 8.2.9, the 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, an object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMAScript object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings, the string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43. Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration n. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration. Has lexical declaration n. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property n. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var n. Determines if a corresponding create global var binding call would succeed if calls for the same argument n. Can declare global function n. Determines if a corresponding create global function binding call would succeed if calls for the same argument n. Create global var binding n. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If t is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding n v d. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding, n. The has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, return true. Let objrec be envrec. Return. Objrec has binding, n, 1, 1, 4. To create mutable binding, n, d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, throw a type error exception. Return. dclrec create mutable binding, n, d, 1, 1, 4. 3 create a mutable binding, n, s. The create a mutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, throw a type error exception. Return. dclrec create a mutable binding, n, s, 1, 1, 4. 4 initialize binding, n, v. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, then a return. dclrec initialize binding, n, v. Assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return. objrec initialize binding, n, v, 1, 1, 4. 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. If the binding is an immutable binding and s is true, a type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, Error handling is determined by S. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding N is true, then error return. DCLREC set mutable binding N V S. Let OBJREC be envrec. Return. OBJREC set mutable binding N V S, 1 1 4 6 get binding value N S. The get binding value concrete method of a global environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is N if the binding is an uninitialized binding throw a reference error exception. A property named N normally already exists, but if it does not or is not currently writable, error handling is determined by S. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding N is true, then error return. DCLREC get binding value N S. ECMA International 2024 145. 3. Let OBJREC be envrec. Return. OBJREC get binding value N S, 1 1 4 7 delete binding N. The delete binding concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete binding
Okay, this took
subject to deletion. It performs the following.
a lot longer than expected.
A return. DCLREC delete binding N. Let OBJREC be envrec. Let global object be OBJREC. Let existing prop be has own property. Global object N. If existing property.
So
OBJREC delete binding N. Be if status is true and envrec contains N. Then I remove N from envrec. See return status. Return true, 1 1 4 8 has this binding. That has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1 1 4 9. That has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 4 1 0 with base object. The with base object concrete method of a global environment record envrec takes no
1 second.
called. Return undefined 9 1 1 4 1 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9 1 1 4 1 2 has var declaration N. The has var declaration concrete method of a global environment record envrec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains N, return true. Return false, 1 1 4 1 3 has lexical declaration N. That has lexical declaration concrete method.
This computer is really laggy.
It determines if the argument that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCLREC be envrec. Return. DCLREC has binding N, 1 1 4 1 4 has restricted global property N. That has restricted global property concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let O be.
Let's make it faster.
1.1.4.1.5 can declare global var n. The can declare global var concrete method of a global environment records envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument n. Redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be has own property, global object, n. If his property is true, return true. Return is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created. Name is a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 146.
Okay, so this is what Chapa gave me for like SB test, whatever. I don't know, the naming stuff like
String, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding
Chapa named the variables Galaxy Fuel, Toaster Echo, Pixel Magma. I don't know. The names or whatever. I found the macros and stuff.
prop is true, return true if is dated
to run this whatever, but I need to make a parser to handle it, because it's really complicated, and I basically have to like churn out a whole new a whole chunk of stuff for each I'll call it a unit, like compilation unit. And one of the things I gotta do when I make the engine, or like when I make the engine like compliant with this standard, this STD, because STD, that's a, I don't know, that's a shorthand for standard STD. I forgot what I was saying. I think it was feedback from like
function binding n v.
Okay, so
Concrete method of a global.
this isn't going to be a fair speed test, because like I was saying, like it has to, there's a whole bunch involved, and I have to run some other files to run files to prepare the file, and I need a parser to do that. Realistically, it'll take way too long. But what I can do, by a not fair comparison, I mean that my JavaScript engine is going to run slower, because when I run it, I'm not going to get higher optimization. I have the engine set up so like the local things like Pixel Magma, whatever this chatbot named it, when it's local, it's grouped with other local things, and it's like inlined or whatever. So there's like a local scope for things. It also a 2 or something, I don't know. Just use here too, whatever.
Same sequence of proxy trap calls, comma 1.
The name itself,
Scope of an ECMAScript module.
the whole thing becomes, I tear it apart into logical whatever pieces and parts. It's not okay, so there's a bunch of stuff that goes on. The local things are optimized higher, but I can't use those macros without adjusting some of the tables and how it's set up right now. I need to like put this test at the end of everything just to make sure all the other stuff above it completes, because instead of using local variables, I have some global variables for the situation, like before, because I don't have time to like optimize for like, it's not optimizing, it's what I need to put in place when it's a local variable, so it gets the speed boost or whatever. It's compiled differently. Not compiled differently. I use a different structure for it internally. So when it compiles, it's treated differently than the global things, and it gives the C compiler the chance to do like C optimizations on the type as it is, instead of having a couple extra things that go on when it's global. So I'm not going to get those little speed boosts. So when I run it, it's going to be a little bit slower. It should still be faster though. But it's not going to be as fast as I want to like compare against. So instead of like using friction mix 1, 2, 3, 4, whatever, I have globals, and I'll use those in place of locals. And then I think I gotta find a couple more macro wrappers. I can make the function, get the do loop, and then there's like a bunch of steps or whatever. But I have an example of a function with a do loop. I just have to like put some of the stuff in place, whatever. I'll use globals, so it won't be as fast. And I have macros for like constant numbers, so the C compiler can do a multiplication, and it uses the constant on the right hand side, which is 177 in this case, as like a straight up C multiply with the constant. And there's like no JavaScript JavaScript not like data type conversion or anything going on. It's just literally the left hand side times there's whatever overhead incurred, if there's overhead incurred, because it depends. It's at least one memory reference if it's cached. If it's not cached, there's a couple cache layers, and it gets a little bit slower. But when it's being used, it's one dereference every time, because things get so it's that times the right hand side, and that's what makes it so much faster. It's literally whatever. So I'm not gonna get that either. I think I'm gonna just make these into globals too, and it should still be faster. So let's see if we can find a global. I'm trying to find a global. Okay, so I found the globals. I had to like whatever. These are the globals that I think I can use as long as I call it at the very end of the main function, whatever. I'm like, well, at the end of main, there's nothing called after it. There might be, if main is, main might be called more than once. I don't know. I'll just put a boolean and not enter again after it's run once. Or I'll just return after it's done. And I'm pretty sure nothing will be using these or whatever. So I think I have 23 globals. I don't have time to churn out a whole bunch of stuff to like remap variables that are named specifically pixel magma, friction mix 1, 2, 3, galaxy fuel. So I'm gonna use these, whatever. I can actually rename these to match the global name. But I'm gonna leave this as it is. I'll just use globals for mine. Are there even 23 variables? I'm hoping there's no more. If there's more than 23 variables, I'm gonna like remove a couple of these so only 23 are used. Because I have these are the only ones that I'm sure if it's called at the end, it doesn't really matter because it's not going to enter again. But they're like they have like names for specific things. It's hard enough to read anyways. It's hard enough to read anyways, so it doesn't matter if the name matches. I'm just gonna whatever use these because that's why I made 23 of these and hope 23 is enough. So I'm gonna like make a copy of this. And count how many variables I'm going to need and hope it's less than 23. This program is eating up memory. But, pixelates the screen. So that's one. This is 2 variables. This is so boring. 3 variables. 4. 5. I should have made a list of these as I replace them with hex, so I could like just rename things and not have to do it again. Oh well, I'll just keep going. 6 variables. 7. 8. 9. 10. I think I can find the integer constants code to wrap the stuff in whatever for that data type. What was that, 9? I don't know. I don't know. Maybe like 14. There's definitely enough. 23 is more than enough. So, worst case scenario, I have to make this all globals. But I have enough globals. So, I'm gonna do that, I guess. push like the array object type in JavaScript prototype, whatever it's called. I don't have like a push call to like push things to it, the array. So I'm going to like make a counter and then increment it, set it to whatever it's pushing to the array. I don't know. That's one more global. I still have enough though. So I'm like tweak this and then this computer is like extremely laggy. I might need to restart it. I don't know. I'll click somewhere and then it like unclicks and then it does something somewhere else and it's like this computer is it's a potato. It's like a legitimate potato. I don't know, I think it's a screen pixelizer program, or it's Visual Studio that's still running. It's like 18%, it's not doing anything. I don't know, something's making the computer lag. I think I need to like simplify this a bit more. Or not. I gotta check it. Like I could put this in. Like I could put this increment, whatever, inside of the array access here. But I would need to find a couple other macros to place an operation inside of an array access. So I'm gonna like move it outside of the array access. So it's like almost one-to-one. But not really, because it looks nothing like JavaScript. It's just turns into like a big blob of like metadata. It looks nothing like JavaScript, but it functionally is the same exact thing. Because it runs whatever. So like, I'm gonna like check the rest of this. This is so boring. I just spent however long like trying to dig through and find random crap related to other things to figure out what's where. I don't want to do this right now. But at least I need to like, I don't need to. I want to like, I don't think I'm gonna get to the types. I'll do it tomorrow. I can at least get this done maybe in a bit. And feel like some progress, whatever was made. This part right here. I don't know. The stream went on. I've been doing this for too long. I'm like, I spent too long explaining stuff earlier. I think I'm gonna like cut out some of the explanation, make like a video out of it, so I don't have to explain again, because I said I'm gonna explain it again. I explained it once. It's good enough. I'll just keep whatever I said. Not explain stuff and record it again. Just take time. But this whatever is an object. And it's setting like 4 values, whatever, to 4 different keys of the object to assign it, whatever. I wonder if JavaScript does look ahead on the store operations if it writes to multiple locations on purpose to like get the most throughput, whatever. I'm gonna like Google that really quick because I need some kind of distraction. It's been a while. Other than like taking breaks and eating food. That's like a necessity. It's not. I don't like certify that as a distraction or something to keep me occupied, because this is really freaking boring. Like, check a couple more lines and then I'll Google some stuff, then get back to this. I think I might be able to find the macro to nest an operation within a object access. So I'll just leave these. Put like perhaps in parentheses, or I don't know, whatever. It's just, I think the rest of this looks okay, and it should convert. I don't have like full JavaScript support until like I go through this whole standard. Then everything will be, I'll be able to like, when I go through the standard in hopefully 2 months. So hopefully in 2 months when I go through the standard, my JavaScript engine will be able to like run this as is, and it'll have, it'll zoom, it'll have this push operation that I don't have right now. I'll have to add that because this is in the standard for array type objects. And since I don't have that, I put a count or whatever. It's the same thing. Okay, so this should convert. I want to like Google something on the modern, the current. You know, like things are current because they're not anchored in the 1970s, 1980s, because things are modern. And as a society, we get more intelligent, so things advance and they don't stay stagnant. Well, I don't know. Who am I to judge? But it seemed, yeah. So the modern JavaScript implementation, I'm gonna look up if modern JavaScript implementations support write operations that are like geared for targeting the CPU and its ability to write to multiple data ports if they're different locations at the same time. Because modern, since, well, CPUs have come a long way, it may be microcode and software driven, but technically speaking, it's a lie. It's all hidden under a clock cycle, or a, whatever you want to call it, an instruction time. There's like, okay, whatever. Technically, but I don't know how to word it. If you play by the artificial rules, you do get benefits. Like, when you load things up in a memory, there's a what's it called? Okay. The newer processors have larger fetches and cache lines. So when it loads up code and it doesn't run it, it's more of a cost because it had to load up a whole cache line and may have computed a whole pipeline of code. And if the execution unit doesn't run that code, all of it's wasted. So, physically and technically, there is a benefit to having the CPU take and run that instruction, all the instructions in the pipeline, and have them complete. Even though, technically speaking, it's wasting time doing that in the first place. I don't know what I'm getting at. I'm like micromanaging. I'm gonna just Google something. It doesn't really matter. But the fact that, like, if they try to even account for that, that's what I'm trying to figure out. Because that kind of matters. Because this is the modern JavaScript implementation that are currently in use. So if they're modern, I would like think that these are the kinds of things that they would gear and direct the JavaScript engine towards doing and accounting for, because they're modern. how to spell that. That's so fucking long to spell. Okay, I don't know, whatever. I can't commit the brain cells to memorizing spelling that. Like, I really don't care. I'd rather know how to spell 10 other things other than the word simultaneously. But I don't care to spell those 10 other words either, because I don't give a fuck for spelling. I don't want to... People proofread, though, for, like, a living. And then, I don't know who would enjoy that job. But then, they get their jobs replaced by spell check. Which sucks. Because if someone enjoys spelling, let them enjoy spelling. Don't replace their job with the computer. Like, seriously. I don't know. Okay, so ask chat about this.
Centered canvas. JavaScript CPU parallelism. Simultaneously. Google search. Skip to content. Is JavaScript designed to take advantage of the CPU, its ability to simultaneously write to multiple data ports at the same time with a script like exobj cat equals 1, exobj dog equals 857.67, exobj alkedhef equals blag, exobj this is a key to an obj like air equals 8,947,539,857.
Man, Siri really sucks at pronunciating some things. So, here's what chatbot says to that.
Great question. JavaScript, by design, does not directly take advantage of the CPU's ability to simultaneously write to multiple data ports, at least not in the way lower-level languages like C or assembly might.
So, I don't know. That doesn't sound very modern to me, that JavaScript wouldn't account for the modern processor. right? Or no, I don't know. Well, here's an excuse. Or not an excuse. It's within context, I guess you would say. So, when in context, chatbot says this is why.
Spanner, JavaScript's execution model. JavaScript is single-threaded by default. That means operations like exobj, cat. Spanner, JavaScript's execution mod. Spanner, Spanner.
I don't know if chatbot doesn't know what it's saying. It doesn't have anything to do with threading. It's instruction ordering. Okay, whatever. I'll let chatbot just say what it's gonna say. Chatbot is literally, it's not smart, and it's not real, and it doesn't know anything until they type it in. I'll let it, this is what chatbot says, even though I'll just say it's right.
JavaScript is single.
This thing's like stuck. It won't stop, like, reading the same spot. What the fuck? Okay, I guess it's like stuck on. And it just keep whatever.
JavaScript is single-threaded by default. That means operations like exobj, cat, equals 1, exobj, dog, equals 857.67, are executed sequentially, not in parallel, even though...
Chatbot sucks. Chatbot is not technical in any way. Oh, it's all lies.
JavaScript is single-threaded by...
Oh, it's restarting the whole thing.
Even though those lines look like multiple things happen... Even though those lines look like multiple things happening...
And that's what the CPU is. They got multiple cores, one execution unit. So a multi-core CPU doesn't mean multiple processors on one processor. There are multiple cores, one execution unit, which carries out execution across multiple cores, one at a time, not multiple. Intel designed a CPU, whatever the name of it was a complete failure. It never worked. It was way too complicated. It does things one core at a time. But, okay, whatever. I don't know. I'll just let chatbot answer it. But the whole, like, multiple things happening at the same time, and the way that CPU manufacturers, and I don't know. It's misleading, all of it. Like, the whole, like, multiple things at once. There's no such thing. It could be possible to have multiple things happen at the same time, but the complexity and the money, and they have boards, motherboards. They have 2 full-blown CPUs on them, but you don't really get the advantage of having 2 CPUs because they gotta synchronize and stuff. There's a different... The way that they design it is inefficient. There are other ways to do things, but currently, the way they do it, there's no benefit, so they put like one CPU on a board now. So the whole multiple things happening at once, chatbot is right about that, but yeah, I don't know. Well, I can't really explain it because of context.
Even though those lines look like multiple things happening, under the hood they're handled one at a time by the JavaScript engine, like V8 and Chrome Node.js.
Oh, it's chat like it's like I guess it's like gonna keep going. Here's what else chatbot says. Oh, here we go. Okay.
Out of order execution. Instruction level parallelism. Memory level parallelism.
Okay, those are the answers, or not answers, the bullet points like they're here that I was expecting. This part.
JavaScript is single-threaded by default. That means are executed sequentially, not in parallel.
The way that's worded, it's like, I don't know. But when it brings up this point, it's like, oh, okay, that's more on, spot on.
CPU level parallelism. Modern CPUs do have features like out-of-order execution, instruction level parallelism, memory level parallelism.
And then it says, chatbot.
But JavaScript engines leave those optimizations up to the CPU and compiler, rather than trying to explicitly parallelize assignment statements like your example. So while the CPU might optimize a few independent operations internally, especially with JIT.
Oh, that's misleading as fuck.
So while the CPU might optimize, especially with JIT compilation in V8. Especially with JIT compilation in V8.
That's a total lie. Okay, so it sums up, in context, that total bold-faced lie statement with
especially with JIT compilation in V8, there's no guarantee, no control from JavaScript code.
oh, it's a whole lot of nothing. Oh, there's more of an answer, I guess.
In short, your line. Dart is executed one statement at a time, in the order written, even though the CPU might internally optimize at a micro level.
I like this part here.
Even though the CPU might internally optimize. Even though the CPU might internally optimize. No guarantee. No control from JavaScript code. Might optimize a few independent operations internally. Might. Those optimizations up to the CPU and compiler. Especially with JIT compilation in V8. No guarantee. No control from JavaScript code.
So,
CPU might internally optimize at a micro level.
nothing will be optimized at a
Micro level.
when running
especially with JIT compilation in V8.
as the
Compiler.
because there is
No guarantee.
what even is this sentence?
Would you like to explore how to use web workers or shared array buffer to get actual parallelism in JavaScript?
Did it not just
JavaScript is single-threaded by default.
I don't believe any of this. Anyways, I'll pick this up on the next stream. It's getting late. It's gonna take me more than like 5 minutes to convert this. It's gonna take like 20 minutes or something. I don't have the attention span for that. So I don't think I'm gonna be done in 5 days. I can try. But I got this ready. Whatever. I checked it. All the operations I know. I support whatever's I just modified it. I have these 23 globals. So tomorrow I'm going to, I don't know, just like if I use global 8 for pixel magma, this is what I mean basically, but like instead of like being a var that's like local inside the function, it'll basically be like this, whatever. It's not clicking. This computer is really, I gotta restart it. Something is like eating up memory. I should did find all. I don't know why I'm clicking each of these individually. I just messed it up, so it's just find all. So global is like outside of the scope. I'll just set it to 0 or undefined. So basically I'm gonna replace all these to not use a local var, but to all be global. And they'll be, which means that they're outside of the scope of the whatever function it is, for simplicity's sake. Need some water, I can't talk. Well, I can talk. I'm talking so I'm done, I can't. I'm so bored. Here's for tomorrow. So instead of also having the name of the or whatever, it's gonna be global now. So functionally, it's the same exact thing. If anything, mine will be my JavaScript engine, whatever, when it runs. The globals will take a teeny performance hit because they're not locals. So if anything, my JavaScript engine is going to run a little bit slower, so I'm at a disadvantage. But to find the macros and adjust the data that I have to like churn out to make it a local will take way too long. I gotta really dig in and sort some of this program out. So I'm gonna do that later. So for now, tomorrow, I'll use globals in place of locals. And I could just make the JavaScript test itself use globals too. But I'm gonna give the web browser the benefit of the doubt. I'm gonna let it get a head start and use the local variables because it's the modern web browser. And since it's a modern web browser, you would think that, I don't know, I'm gonna run the JavaScript as it is, which is using local variables, so it doesn't have to use globals, so it'll be faster. And then I'll just use globals for mine. I'll just take the hit, because I don't have the time to, at least right now, I'm gonna have to really, once I go through and convert things to 64-bit Foley, I'll end up coming across the files that I'm looking for, and I'll be able to like piece together what goes where and then recognize whatever, and then I can like, oh, I gotta do this, and then whatever. Until then, I found like a couple spots, but it's really like entwined with a bunch of other things. So I'll use globals, and oh, that's tomorrow. I'll do this first. I'm not gonna waste time doing a little rant. I explained why I'm streaming earlier, like for 40 minutes. So I'll like make that a video, like a separate video, so I don't have to keep going over it. I don't know. That's I'm done for today. So tomorrow, I'll just like keep repeating myself. I want to do this, but I can't. I could, but I have like anxiety. So I'm gonna stall and do this tomorrow. Heavy anxiety. Alright. So tomorrow, I'm gonna do this, and then I'm gonna finish with types, and then I'll convert 32-bit to 64-bit. Like I said, and what is it? Oh no, what is it? Oh, this is it. Like I said in earlier, whatever, like really long explanation. So tomorrow, I need to make like an actual to-do list so I can like I need to drink water too, so I can like just like go like this, and if you can read it, then you can read it. If you can't, man, this computer's so laggy. It grabbed the desktop when I was clearly, you see the icons? I clicked in Sublime, see how it's highlighted? And then somehow that clicked into the desktop. And instead of resizing the text, it's resizing the desktop icons. I have never made the desktop icons this large. They get pretty big. So I'm like, rescale these desktop icons. This computer is so laggy. I don't even know what scale was at. Everything's all over the place now. like messed up my desktop. Nothing's where it was, I don't think. So, I'm gonna click here again. If the computer's not lagging, it'll zoom. Oh my fucking god. This potato. I'm gonna release the mouse inside of the text editor this time. I released the mouse, now it should zoom. Oh, there it goes, okay. Like, I go like this, I'll release the mouse, but if I like, okay, whatever. So, this is what I was going to do. If you can't read it, then you can't read it. Whatever. So I'm doing this tomorrow. First thing first, I'm not gonna do a little rant or waste time because whatever. Then I'm gonna do this tomorrow. And I should. Tomorrow, I'm gonna aim for these two things. It's like day 5, I think. Is today day 5? I don't know. Day 4, assuming today's day 5. I'm gonna do 64-bit addressing. And hopefully, in I guess 4 days now, I'm gonna convert this whole thing, this entire thing, to 64-bit. That's the goal. If it takes longer than 4 days, it takes as long as it takes. But I'm planning for 4 days. So tomorrow, these two things. In 4 days, it's freaking laggy. 4 days, this. And then I'm gonna do the, oh, I forgot. I gotta do this too. Do the OpenGL test to speed test, show that mine's faster and it can handle actual video games. I'll change the workload to see when the web browser starts to lag and if mine lags with that workload or if mine can continue to do more work at a 60 FPS whatever, and how much more work. If my JavaScript engine is faster, more than twice as fast, I'm not going to show that. I'm just going to show like up to twice as fast, because anything faster than that, once I add support for the standard 800-page ECMA, once I add support for that, it's going to affect the overall speed. How much? I don't know. But if it gets slower from doing that, which it will, probably most likely a little bit. If it does get slower, it'll be slower than whatever the speed is. So if it's over twice as fast, I'm not going to show that. I'm only going to show, yeah, I just explained it like 3-4 times. And then, well, like I just said, I'll go through this. So, this tomorrow, for sure, I should have enough time if I do this all day and I keep the ranting and random whatever to a minimum. I should be able to do this in a day. This, I plan to convert this whole thing in 2 weeks. I think there's 5 days or 4 days left. This will be the next 4 days of that. 4 days left of the 2 weeks. I started the count at 13. After that, I'll be doing the OpenGL test. That'll probably take maybe 4 days, because I want to test other things too. And I might want to make like an ogre in Blender, and like animate something running around in OpenGL. I have like 20 ogres dancing or something. I'm saying ogre. I don't know if like Shrek is trademarked, so I'll make an ogre. Just be like a generic ogre, like, you know, like the horrible memes where like Shrek is love or Shrek is life. I don't want to like take and use someone else's. Unless they can give credit, then I'll do that. I'll use their ogre, but I'll like animate it and have it like dance around or something for the frame rate test, and then I'll put like 20 ogres, 100 ogres, see until the web browser starts to lag, and I don't know. I also want to test other things. I'm not gonna give out the numbers until it's done, but just whatever. So it might be 4 days. After that, we'll be going to the ECMA, whatever. I'm planning on 2 months. See how the 2 months goes. All these things, the timing is extremely optimistic. So I'm making everything sound like it's a smaller undertaking than it is. So it's more makes me feel like it's more manageable until I hit the deadline, whatever. I'm like, shit, I'm not done. And then I'll like speed up and try to get stuff done really quick. But I won't screw up perfection. So like I'll get done, but I'm still gonna get like the kiss of perfection with everything, whatever. And then after that will be the epilogue. After the 2 months of converting to fully support the standard, whatever. I'm gonna like finalize the thing. I'm gonna optimize stuff that's bottlenecked or whatever, and add things to it. So to like extend browser support for other vendors and stuff. So that's it. So tomorrow, whatever, I'm gonna like see everything again. I'm doing this and this. And peace. I'm gonna like let the stream run on for like 10 more minutes because this is a modern streaming software called OBS. I'll just find it because everybody doesn't know what OBS is. It is a wonderful experience. It's like this amazing, beautiful program. It's modern, it's very modern. It's been updated over years. And it's just great. Let me pull it up right here. I gotta type it in. So it's called OBS Studio, okay? This streaming software is very modern. It has all the modern glitches, the modern bugs, the modern, just everything modern. This thing is modern to the max. Since it is modern, it does this thing where, when I say they, I mean whoever made this website for OBS. People do this thing these days, this modern thing, where they say things in context, and this sentence on the main webpage is it's in context. This I'll have a Siri read it.
Download and start streaming quickly and easily on Windows, Mac or Linux.
So this right here.
Start streaming quickly and easily. Start streaming quickly and easily. 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 Easily.
So since it's so easy to stream on this software, in context, of course, I'm going to let this stream run on for 10 more minutes. Because the end of the stream doesn't always send, so if I give it 10 more minutes, it might send the full stream. Sometimes it does send everything. Every now and then, the end of it gets, like, it just doesn't make it. So, I'm gonna put B or B, whatever. I'm gonna drink some water. I talked way too much. I'm gonna let the stream run on for 10 minutes. That's also why I'm stalling, because, I don't know, I kind of want this to be at the end of the video, so I want to, like, say a bunch of stuff. So if it does cut out, this will most likely be in it, this little promo, this positive, contextual endorsement for this wonderful, modern streaming software that I have to let run for 10 more minutes because since it's modern, it doesn't send always the end of the stream. So now, when I let it run for 10 minutes, it may, who knows, I don't know. It could possibly send the whole stream if I let it run on for 10 more minutes. So, peace. I'm not gonna be back. Just saying. So like, it's gonna run on for 10 more minutes.